Hey everybody, tonight we're debating whether or not the Earth is at the center of the universe, and we are starting right now. Ladies and gentlemen, thrilled to have you here for this epic debate. This is going to be a fun one, folks, and want to let you know if it's your first time here at Modern Day Debate, we are a neutral platform hosting debates on science, religion, and politics, and we want to let you know, no matter what walk of life you are from, we really do hope you feel welcome, folks. So welcome. Thrilled to have you here for this epic event. It's going to be a lot of fun, and also want to let you know a few things up front. If you love controversial debates, if you're sick in the head like us and you love juicy debates that push the envelope, well, want to let you know, consider hitting that subscribe button, as we have many more controversial debates to come. As you'll see, for example, at the bottom right of your screen, we are thrilled that next January, on the 8th, which is a Friday, we are going to be hosting Dr. Michael Shermer, New York Times bestseller, and you could say a hugely popular Christian apologist, YouTuber, inspiring philosophy, Mike Jones, will be debating whether or not Christianity is dangerous. And huge update, you guys. We are really excited about this. Last night we hit the goal for our Kickstarter. We are thrilled. So that debate is for sure happening. I'd still encourage you to sign up, as that's going to help us. We're basically right now I'm getting feedback from people on what we'll actually use. We're doing a stretch goal. Basically, we're trying to go beyond our original goal of 2,500, which you see there on the meter on the far right of your screen, and want to let you know we are now going for a total of 3,000, and so we'll be using that for potentially another monster debate. We'll keep you updated as I get feedback from others on that. So with that, want to let you know we are thrilled to have our guests here. Oh, and the last thing about the Kickstarter is linked in the description, just so you do know. And our guests, I'm very excited about this. We've never had this topic, and we also have two articulate, quick on their feet guests. I want to read you a quick bio from Dr. Sungenis. I appreciate your patience with me, as I hope, forgive me, let me know if I've got it right that time, Dr. Sungenis.
You're doing well.
Sungenis, thank you very much. We want to give you a quick biography reading. First, Robert is an international author, lecturer, debater, producer, and founder of Catholic Apologetics International Publishing, a nonprofit corporation dedicated to teaching and defending the Catholic faith. He holds advanced degrees in theology and religious studies from George Washington University, Westminster Theological Seminary, and, oh, this is another one. Let me know if I pronounce, is it Calamus International University?
That's right.
Thank you very much. I appreciate that. And so, do encourage you to check out both of our guest links. You have seen Leophilius here before. We're thrilled to have you back, Leophilius. But what I want to do is first just ask, guys, we're thrilled to have you. Thanks so much for being here. So we'll start with Dr. Sungenis. We are thrilled to have you. What can people expect to find at your link that I put in the description?
Which link is that?
We
have several.
Double check. It was the one that your secretary sent to me, but I'm going to double check just to be sure I've got the name of it.
Well, I can give you, the rundown of all three of them if you want.
I've got journeytothecenteroftheuniverse.com.
Yeah, that has all our science issues, our DVDs, CDs, books dealing with creationism, geocentrism, cosmology in general, physics in general. Nothing theological there. The other link is robertsungenis.org.com.net, and that deals with all the other issues related to my degrees in theology, politics, culture, things of that nature.
You bet. Thank you very much, Dr. Sungenis. And we'll kick it over to Leo. He has been here before. He is articulate. He's fast on his feet. Leo, we're thrilled to have you back. Can you share what people can expect to find? Absolutely. And can you share what people can expect to find at your link in the description below?
So that would be a link to my YouTube channel, and there I correct pseudoscientific misinformation, just because I feel that that needs to be done. A lot of people in the scientific community, actual professionals, they either don't do it or they're too technical and too formal when they do it. So I am engaged in a lot of science education, science communication, mainly with a focus on astrophysics, cosmology, and quantum mechanics. I also do a little bit of creationism and intelligent design busting on a good friend of mine's channel. The channel would be Speed of Sound of Gravity. That's about it. I might do a little bit of politics on my channel. Haven't gotten that far yet, but hope I can get a little bit of politics out there as well.
You got it. Well, thanks so much. And with that, we technically usually have the affirmative go first. In this case, given that the question is the Earth the center of the solar system, or more broadly, universe, it would be Dr. Sungenis. However, it's up to you guys if you guys have a preference on Leo going first instead.
I would prefer Robert go first because he is taking the affirmative if that sparkles with him.
You bet. Well, Robert, the floor is all yours. Thanks so much. And I've got the timer set. Want to let you know, folks, our format will be roughly 10 to 12 minutes from each side, followed by open discussion for maybe about 50 minutes or so on average, and then about 30 minutes of Q&A. So if you have a question, feel free to fire it into the old live chat at Modern Day Debate. Thanks so much. And Robert, the floor is all yours.
Okay. Well, let me just say, first of all, that I know that when people first hear this topic, that the Earth is in the center of the universe, all kinds of bells and whistles go off. And they did with me when I was first introduced to this. I'm not a conspiracy theorist. I don't believe the Earth is flat. I don't believe there's Martians. I don't believe in a lot of things that are tossed around today. But I have a special interest for geocentrism because, as we know our history, the church took this on with Galileo, my Catholic Church, and condemned the idea of heliocentrism or Copernicanism, and stuck with the traditional view of geocentrism. Now, the view there was the Ptolemaic view. That can be shown to be, although close, it's wrong because it puts Mars and Venus in the wrong place. And then we had the Tychonic geocentric system come along around the 1500s. And what this did was it just inverted the Copernican system. Instead of having the sun and the planets go around the Earth, it had the sun go around the Earth, but the planets went around the sun. And if you know anything about this topic, you'll understand that that's just an inversion. And it also developed later into the neo-Tychonic view that allowed us to have an answer for stellar parallax and stellar aberration, things like that. And they're important because they were used as proof for the heliocentric system, at least until society was taught that the geocentric system under the neo-Tychonic model has its own stellar aberration and its own stellar parallax. It can show those just as well as the heliocentric system. So as the heliocentric system went through phases, like when we first had it, we had Pythagoras, who believed that the center was a big fireball and that the sun went around that. And then we had Aristarchus of Samos, the Greek from the 3rd century BC, and he basically has the fundamentals of the Copernican system that was followed before Copernicus came along, somewhat 1800 years later. And Copernicus basically got his model from Aristarchus. But Copernicus's model didn't work too well because he wanted the planets to go around in circles, perfect circles around the sun. And about 100 years later, Kepler came along and made them into elliptical orbits. And that got closer to what we see in the sky, but it's still not perfect, actually. A lot of people don't know that, but it's not perfect. But so as the heliocentric system has had development, so the geocentric system has had developments. And the latest model now is the neo-Tychonic model. It's easy to say it, it's not easy to explain it, but basically the Earth is the center of mass for the universe. It's not the geometric center. the geometric center for the universe is the sun. And that means that the stars are aligned with the sun, and both of them go around the Earth, which is the center of mass. In order for that to happen, the whole universe has to rotate around the Earth once per day. Now, again, when people hear that, they, all the flags go up and they say, well, that just can't be. Usually, and I would say probably 95% of the time, the person that says that has never studied it. And sometimes I like to compare it to the flat Earth, because although the flat Earth is wrong, it's not easy to get there. Let's put it that way. If you've ever studied, I wrote a 700-page book called Flat Earth, Flat Wrong, showing that from science, from history, and from the Bible, the Earth is not flat. It's a sphere. But in some places, that's hard to show, okay? Like if you're trying to look over Lake Michigan at the Chicago skyline from the other side of Lake Michigan, yeah, it does drop down 900 feet, okay? But the trick is explaining that. The way to explain it's not because the Earth is flat, it's because the air is refracted, okay? So you can get to it, but it takes some knowledge of science in order to get to that position. It's the same with geocentrism. You just can't come into it with a knee-jerk reaction and say, oh, well, that's impossible. The sun's bigger than the Earth, and that means the Earth must revolve around the sun. Yeah, well, that's the way it used to be in Newton's world, okay? Newton himself admitted that if we include the rest of the universe and the forces that come from the universe, we could have a geocentric universe, the Earth in the center and everything going around it. He admitted that, okay? As did Albert Einstein, admitted the same thing. As a matter of fact, Albert Einstein said that Newton had a defect in his mechanics because he wouldn't allow the universe to be involved in calculating what the forces are going to be that determine what goes around what, okay? And most people just don't know this. I've talked to physicists who are experts in special and general relativity who don't know this because they've never been taught it. But if you read Einstein's actual works, that's what you find. And if you read Newton's actual works, that's what you find, okay? It was easy for Newton to have F equals ma and F equals GMM over R squared because he confined his model to our solar system. And if you do that, well, yeah, I would admit the Earth has to go around the sun. If the model you choose is the solar system and you exclude everything else, that's the model you're going to end up with. But 200 years later, a guy named Ernst Mach came along. He's the guy that, we named the speeds of jets from, Mach 1, Mach 2. Ernst Mach said, well, Newton cannot make that assumption that you can exclude the rest of the universe. You see, in order for Newton's system to work, he had to have an absolute. And absolute space was one of his first absolutes he had to have, and he also had to have absolute time. And in order to have that, your universe has to be inert. It can't move. You can't have any function that's going to impinge on our solar system, you see. So that system was the going system for 200 years. It was supported by all the philosophers, Immanuel Kant, everybody. And Newton became a household name because of that. And as I said, Mach came along and said, well, you can't have Newton's system because you're making an assumption without any empirical evidence, okay? How does he know that the universe doesn't move? You just can't assume that and then work out all your equations so that they fit your model. You have to include the universe, and if the universe can move and it's not inert, that means it can rotate. And if it rotates, that means the Earth can be stable, fixed, and not move. And so basically, you would have an inversion. Instead of having an Earth rotating in a fixed universe, you would have the universe rotating around a fixed Earth. This is what started the whole idea of relativity. Einstein, when he came along, was enamored with Mach. His whole special relativity, his whole concept of relativity was based on Ernst Mach. And so if you look at Einstein's general relativity, which is ironic because we have to go to general relativity to find support from Einstein for geocentrism, whereas his previous theory, the special theory of relativity, invented in 1905, was invented precisely to keep the Earth moving when all the experiments that were performed in the 1800s by Arago in 1810s, by George Bedell Airy in the 1870s, by Michelson Morley in 1887, they were all showing the Earth wasn't moving. And basically the science community was scratching its head. How are we going to explain this? Because we've believed in heliocentrism since the time of Galileo, for Pete's sake. And all of a sudden we have these experiments showing that the Earth could be fixed in space. Well, Einstein invented his special relativity in order to fix that problem. And in special relativity, the speed of light becomes constant, and therefore the Earth can move. If he had made the speed of light not constant and allowed the Earth to be constant, that is not fixed, that would be the other solution to the problem. But of course, we can't have that, you see, because we're all Copernicans, we're all enlightened, we've been through the Enlightenment, and we're all smarter than the guys that came before us. And so we have to pick the system that keeps the Earth moving. And so that means the speed of light has to be constant, and that means length has to contract when an object moves, time has to dilate when an object moves, and its mass has to increase. That's special relativity in a nutshell. All created to try to answer those experiments that saw the Earth fixed. 10 years later, Einstein invents another theory, the general theory of relativity. This theory was almost the direct opposite of special relativity because it allowed the speed of light to not be constant. Light can move at any speed. The general relativity theory said that material objects can move at any speed. And that becomes important because one of the first objections you get when someone is confronted with geocentrism is, well, how do all those stars and stuff go around the Earth so fast? Well, go look at general relativity because that's what it says it can do. That's where I got it from. Okay. Again, most people don't know that because they haven't been educated. That's what the theory of general relativity says. Light can go any speed, material objects can go any speed. So voila, we have a geocentric universe. Okay. As a matter of fact, the whole concept of relativity demands that you have either a fixed Earth and a rotating universe or a fixed universe with a rotating Earth. One or the other. And this whole concept of allowing both of them to have viability is based on the co-equivalence and covariance equations of Einstein's general relativity theory. Okay, so if anybody comes up to you and says, well, geocentrism is impossible, then they haven't read Albert Einstein's thesis on this whole thing. Okay, so basically what happened was the general theory of relativity was a complete contradiction to the special theory of relativity. That's another secret they don't let you know. In special relativity, speed of light is constant in an inertial frame. In general relativity, there are no inertial frames. They're not inertial. And that means light does not have to be constant. And material objects are not limited to 186,000 miles per second. Okay? They can go at any speed. So how much time do I have left? A couple of minutes or what? You keeping time at all? James, are you there?
Yeah, he's muted.
About a minute. Okay. So, and then so here you come with general relativity. It basically says to us either one can be correct, the geocentric or the heliocentric. We just can't tell you which one it is because our whole theory is based on relativity, not absolutes, you see. So if you don't have an absolute, you don't have any basis to judge. So how do you do it? Well, we can go to stellar parallax or stellar aberration. Well, no, you can't do that anymore, because the geocentric model has shown by the neo-Tychonic model that stellar parallax and stellar aberration are no longer proofs for heliocentrism. Okay, or you can go to the bulge of the Earth, somebody might say, where we know that the Earth has a greater circumference at its equator than it does at the polar circumference. Well, you can't do that either. Why? Well, because all the inertial forces that are created by a rotating universe are going to create the same bulge of the Earth as in the heliocentric system. Okay, so basically, when you go through all the so-called proofs that heliocentrism has had, you find out that they have no proof. They have no proof. And that's where the bottom line is. Okay, so if you have no proof, then what are these guys doing? Why are they all saying that they're heliocentrists and they believe that the Earth goes around the sun? Well, either they're sticking with Newton and forgetting about Einstein, okay, or they make their decisions on philosophical preferences and not on empirical science. And that's where they rest. If you talk to guys like Stephen Hawking,
about 30 seconds left.
Stephen Hawking will tell you he does not base his decision of heliocentrism and geocentrism on the empirical evidence. He makes it by a philosophical preference. Okay? And I'm not even including all the astrophysical evidence that we have now. The cosmic microwave background radiation, the formation of galaxies in concentric circles around our galaxy, all that kind of stuff. I haven't even gotten into that yet.
And time.
All right.
Thank you very much. We are thrilled for that opening statement, as well as for yours, Leo. So the floor is all yours. I've got the timer set. Thanks again for being here.
Thank you. Thank you to the audience, and thank you to Robert for partaking in this debate. Should be a good one. I didn't know precisely how much of geocentrism solar system wise or geocentrism universe wise was going to be discussed, so I kind of put both of those into my opening, more so on the solar system side than on the universe side, for reasons that I'll get to later. The first point that I want to make is that, and I'm only going back so far to what I felt was the most relevant to talk about, Galileo Galilei was capable of making observations that showed that Jupiter had moons and that they orbited Jupiter and not the Earth. And in his mind, this was sort of a rudimentary indication that, what if the Earth and all the other planets that they at least knew about at the time didn't orbit the Earth, but all orbited the sun? And his observations that he made of Jupiter's moons orbiting Jupiter were actually confirmed, I think, rather quickly. I can't remember the name, but it was not very long after that somebody else had made the same observations. Galileo also observed the phases of Venus, like the phases of the moon, which disagreed firstly and foremostly with the Ptolemaic system, which stated that if Venus was between the Earth and the sun, then it would always appear crescent, or like most of it you can't see, hence the term crescent. But if it was beyond the sun, then it would always appear gibbous, or as if it was full in the sky. But Galileo observed a transition between all of these phases, which indicates right off the bat that the Ptolemaic model it can't be correct, and that Venus must orbit the sun. And this led to what is known as the Tychonic model, where I believe Robert mentioned the Tychonic model. And that model was soon challenged by Johannes Kepler, and he developed his 3 laws of planetary motion that were based on a Copernican model. The first one states that the orbits of planets, or the orbit of a planet, is elliptical, not an actual perfect circle. Number 2, a line segment joining a planet and the sun sweeps out over equal area over an equal interval of time. And number 3, the square of the orbital period of a planet is directly proportional to the cube of the semi-major axis of the orbit. And his first law, which established elliptical orbits, drastically improved the accuracy of our predictions, the predictions that we could make about planetary motion. And his model observed and well-documented transit of Venus, both of which corroborate Kepler's model and Kepler's his 3 laws. And his 3 laws, Earth is not at the center of at least the solar system. Sir Isaac Newton came along, and he used his mechanics in an attempt to accurately derive Kepler's laws. He wanted to take the laws of motion that he developed, that Newton had developed, and he wanted to see if he could get Kepler's laws out of those. And he was capable of doing that, which further corroborated Kepler's laws and thereby a heliocentric model of the solar system. Newton's laws themselves were corroborated by numerous experiments, such as we were capable of observing that the oscillatory period of a pendulum is longer at the equator than it is at equator. The observation of stellar aberration by Robert Hooke in 1670s.
One second. But right now it's like intense. So sorry, but I just don't want it to be the case that you're giving your speech. I've paused your time, but
okay.
It's going to be buffering for people, and I just want to give people a heads up if they can hear us.
Is it cleared at all now, or is it still cutting in and out?
Strangely, it's still going red and yellow. I'm like confused because it's like really rare.
What about now? Is it any clearer now?
No, it's still red. I'm a little bit baffled.
So am I. My Wi-Fi network says I have a strong connection.
It's not you. It's on my side. It's my Wi-Fi.
Okay.
So OBS isn't even getting out. So they may not even be able to hear us right now on Twitch or YouTube.
I can check the YouTube stream, and it does look like... yeah, it does look a little robot-y.
I'm running a speed test because this looks bad. I don't know why, but sometimes it will like pop in where it's like, ooh, it like, you know, it dips. But right now our download and upload speeds have like tanked. I'm just not sure what's going on. Let me just see if there's yeah, right now we're
Bitrate must be a little low, I'm assuming.
Let me there's one other hope, you guys. I'm so sorry about this. It doesn't usually happen, so I'm gonna have to ask if, because I just don't know if it's like reliable. Sorry folks, I know I totally okay, I think we're back. Okay, so what I want to do is I think we're back to normal. It once in a while it happens, but that was insane. In other words, like that was just like where it tanked for like 4 minutes straight. It happened last night for like 30 seconds, but I'm traveling, so this is as good as I can do right now. So folks, if you are able to hear me, please do let me know what you are seeing in the live chat, and in about 30 seconds we'll be able to know what they're thinking. The video should be back to normal in about 20 seconds. So
I'm looking at the feed on YouTube, but it looks fairly clear now.
It's surprising that the video is still lagging. So sorry guys. Let me just do another speed test, see where we're at. It's still at 7. It's pretty bad. Strange that's the upload. Well, folks, we are going to... What I'm going to do is, I think we're at least... Yeah, okay, people are saying it looks good now. I think we're back to normal. So, forgive me for that, folks. And... looks like we're back, and so what I will do is give you your time back. So you've got about, I'd say about 8 minutes. So the floor is all yours, Leo.
All right, just to kind of recap, we went over Kepler's laws of motion and how they seem to indicate that the Earth is not at the center of the solar system. Sir Isaac Newton derived Kepler's laws with his laws of motion, which corroborated Kepler's laws. Just trying to figure out where I'm at in my notes here. Oh yeah, it was the Robert Hooke in 1670 something. It was, I think, in early mid 1670s, observed stellar aberration. An aberration is where if you have an object that's moving and you're looking at another object, that object is moved in the direction of your motion by a particular an angle that you could represent with, say, theta or something like that. And that was observed, but that wasn't really fully described until sometime in the early-ish mid 1700s, I want to say, by James Bradley, I believe it was, who by explaining how the Earth orbits around the sun, which corroborated experimentally a heliocentric model of the solar system. In 1838, Friedrich Bessel measured the parallax of the star 61 Cygni, which finally truly defeated Ptolemy's model, because Ptolemy's model stated that parallax did not exist. This also allowed us a method to determine the distance of stars from the Earth, and it shows us that the Earth is indeed moving. My fourth point that I want to touch on is relativity. Now, relativity lends confirmation to the predictions made by Isaac Newton, at least to a point, and by Kepler, at least to a point. It takes it a little bit further, but it also shows that Isaac Newton and Kepler were definitely on the right path, such as, say, elliptical orbits of the planets relative to the sun. It also shows that if we use stars as a fixed reference frame, we would observe the planets orbiting around the sun, not the Earth. Specifically, general relativity easily puts the sun at the center of the solar system, because the sun comprises about 99.4, I believe it is, % of the mass in the solar system. And general relativity tells us that what gravity is curvature in space-time's geometry as the result of mass or energy in space-time. So you could essentially describe the planets as sort of moving within the throes of the sun's gravitational influence, the same way that if you put a very heavy ball on a trampoline and then threw marbles onto the trampoline, the marbles will orbit that heavier ball. This has been observed in literally every single other solar system we have observed in the universe, which is dozens of them. The planets all orbit the stars, whether it's a single star system or a binary star system, because we have observed a few binary star systems that are also solar systems. Albeit relativity does lend confirmation to a heliocentric model, it doesn't prove it, namely because science doesn't prove things. One can derive the same observations regardless of whether the Earth, the Moon, or even Jupiter, Pluto, is put as the center of the solar system. However, this is not corroboration of a geocentric model, but rather of the relativity of measurement, that measurements can be made from any frame of reference and still hold validity. But this doesn't mean that the frame of reference accurately models what's happening in reality. To give an example, you can say that a car is moving 60 miles an hour past a post, but it is just as valid to argue that it's actually the post that's moving past the car at 60 miles an hour. Now, we all know that posts don't move, the car is the one that's moving, but either one of those frames of reference works. You'll get the same exact calculations. That's part of the reason why it's called relativity. Geocentric models are used when dealing with bodies that are influenced by the Earth. Say, if we're looking at how the Moon orbits or how the satellites that we've made orbit, obviously the Earth is put at the center there. But we're not talking about the whole solar system or even the entire universe in those instances. So we are capable of using a geocentric model. As for the Earth being at the center of the solar system, that's pretty much defeated by the fact that the universe doesn't have a center. Mainly because the universe, asking where the center of the universe is would be like asking where the center of the surface, specifically the surface of a sphere, is. There is no center of the surface of a sphere. Likewise, and that sort of gives you an intuitive picture, likewise, there is no center of the universe. Now, many people have argued that, well, we observed the universe expanding outward from the Earth, that it seems that we can look out in any direction and the universe is expanding the same in every direction. That is true. However, because the expansion of space-time is a metric expansion of its scale, not the universe existing as some physical object that's getting physically bigger. That's not what is meant by the expansion of the universe. Because it's a metric expansion of its scale, you would observe the universe to be expanding outward from any point, regardless of which point you measured it from, which also lends credence to the idea that the universe doesn't have a center and is also the consensus of modern cosmologists. It seems to me that a heliocentric model, whether of the solar system or of the entire, or whether if you're going to argue that a geocentric model, whether it's of the solar system or of the entire universe, just doesn't seem to line up with the predictions that we have made and been capable of confirming with the observations that we make. And a heliocentric model, the models that we use currently in physical science today, match up with those observations, and they align coherently with the mathematical descriptions that we're capable of giving. A heliocentric model comports significantly more thoroughly with reality than a geocentric model does. And I would argue that even if by Occam's razor alone, we should consider the heliocentric model to be the defining model for the structure of our solar system, including the motions of the bodies within it. And I will yield the remainder of my time.
Thank you very much, Leo. We'll jump into open conversation. So thank you, gentlemen, especially for your patience with that chicanery earlier. I don't know what was going on there, but thank you very much. The floor is all yours for open discussion.
There were a couple of things I wanted to touch on. The first one was, I think you said, what was it that you said was the reason for Einstein developing special relativity again, if I may ask? You're muted, by the way. Robert, you're muted. I don't know if you have to unmute him there, James, or if he can unmute himself on Zoom.
All right.
Oh, there you go. There you go.
I didn't turn it off, so I don't know how it got on. All right. So I heard. All right. So your question, I know the nature of your question, because some people think the special relativity was invented because of Maxwell's equations. That is not true. And Einstein says it himself in his 1920 Leiden speech, where he said that the Michelson-Morley experiment was the basis for his special relativity theory. Only then, after he tried to answer Michelson-Morley, did he go to Maxwell's equations and try to make them relative instead of polar, which is what Maxwell found. So the basis for Einstein's special relativity was the fact that the 1887 Michelson-Morley experiment showed that the Earth wasn't moving through ether. If it was, it would be moving at a clip of 30 kilometers per second. All they could get from that experiment and all the other experiments that modeled Michelson-Morley was probably about 5% of that. So obviously they didn't find the Earth was moving around the sun, because it isn't moving at 5 miles or 5 kilometers per second. That's what I said.
Okay, so I would say that part of that is correct. So Maxwell's equations did not work with Newton's with what he had developed, because in his model, space and time were fixed and immutable, and it became completely inexplicable. A lot of the interactions, excuse me, that happen in electromagnetism are not, they weren't, we couldn't explain them within that. So it was postulated that, well, maybe there's this ether that light is moving through, and that can explain it. So Michelson and Morley did their experiments. What the experiment was essentially trying to show is that if there is this luminiferous ether out there that light travels through, the Earth should be moving through that ether. And so when you shine a beam of light off of Earth or to the Earth, there should be some sort of drag that it has in that ether, and we weren't capable of detecting that. So we knew that was sort of saying there's got to be something more here. And Einstein said, okay, well, what if instead of space and time being fixed and immutable, they were connected? And it wasn't even Einstein who actually showed that space and time were connected into a single manifold. That was Hermann Minkowski, after which the coordinate manifolds that we use in special relativity are named the Minkowski spaces. And in those, once you begin moving at relativistic speeds, the manifold actually changes, which comported with Maxwell's equations and allowed for a much more thorough description of classical electrodynamics, at least classical electrodynamics at the time. The other thing I wanted to touch on is, if I remember, okay, go ahead.
Let me comment on what you just said. You said a mouthful. Okay, so basically, the problem with your whole thesis is that Maxwell found there were 4 different equations he had to use to explain its electromagnetism. Mm-hmm. Einstein didn't like that because he had to use relativity to explain Michelson-Morley. So if he's going to use relativity to explain Michelson-Morley, he's going to try it with Maxwell's equations. And then he's going to try to combine 4 equations into one and say that, well, it's just an illusion what we're seeing with Maxwell. It doesn't really happen that way. It's all relativistic. Okay, but that's not what Maxwell found. Maxwell found that the speed of light was constant in ether. He believed in ether. Okay, the speed of light wasn't constant by itself. It was constant in ether. Newton also believed in ether. Okay, so yeah, you had a contradiction there trying to explain Newton with Maxwell, but the way to do it was either you said the Earth wasn't moving through the ether because of the Michelson-Morley experiment, or you went with Einstein, you just said, well, there isn't any ether, and the Earth is going around the sun. So you have two viable explanations there. You have no way of knowing that the one you just described is the correct one.
Except the math indicates it thoroughly.
No, the math doesn't do anything. All the math does is put things in numerical equations so that one side equals the other. You can use math to do that with anything. You can do it with a geocentric system.
But then you have incorrections in your math that don't allow you to draw accurate predictions.
See, that's the myth out there. That's the myth.
Are you saying that math can't ever be wrong? Even when it is? So like 2 + 2 could equal 5. It seems to me that you're arguing.
No, I'm not saying that. I'm saying that you can put numerical representations on what you think is empirical evidence that could be flatly wrong. Like, for example, using Lorentz's contraction formula.
Lorentz transformation?
Yeah, the Lorentz transformation. Now, what he did was he made up a mathematical equation to answer why time dilates and length contracts. But he first assumed that length contracts so he can answer the Michelson-Morley experiment. But how does he know that the length contraction and time dilation is the answer to Michelson-Morley?
Because
the opposite of that is that the Earth isn't moving. But he didn't like that answer.
Well, we've actually observed special relativistic effects like time dilation. That we actually have. In our GPS satellites, if we didn't correct for the time dilation effects over the course of 24 hours, your coordinates would be off by 7 miles.
Yeah.
So if time dilation is not a physical effect that occurs in reality, why do we have this observation that seems to indicate that it is?
Well, here it goes. In our movie, The Principal, we had the guy who went into the GPS and analyzed their computer program. And what he found, and this is the guy that works for John Deere Tractor. He's dead now. He died last year. His name is Ron Hatch. He has to make these tractors go in a straight line. And they use the GPS, unmanned tractors. So in order to get these tractors to go straight, not into the ditch, he had to go into the GPS computer program. And what he found was they pre-programmed them with the Sagnac effect. And if you know anything about the Sagnac effect, that's almost the same thing as the Michelson-Morley experiment, because they found that light speed is slowed down when it goes in one direction and not the other in a circular frame. And so to answer your question, the reason the GPS can work as if light is constant is because they pre-programmed the computers with the Sagnac correction. In other words, they know that light doesn't go the same speed east and west from west to east, because that's why they had to put the correction in the program.
I've never heard of that, and
we'll look them up.
I've read books on special relativity that haven't ever mentioned that. I think I feel more.
There's a reason they don't mention.
How do you spell that? The what effect?
Sagnac. SAGNAC.
Oh yes. Oh, I have heard of this before. I just can't remember what it is off of my head.
Let me add something else to it, if you don't mind, for further discussion.
Go ahead.
In 1925, Michelson did another experiment, very similar to the one he did in 1887. He had Gale and Pearson as his workers with him. In that experiment, he is trying to find out the rotation of the Earth, okay, on the sidereal rate. So he sets up his interferometer in Illinois in a rectangular shape, and he finds that the light beams are going in a speed that confirms a sidereal rotation of 23 hours, 56 minutes, and 4.1 seconds, which is exactly the relative rotation between space and the Earth. Okay. So here's the question. Are you listening?
Yes.
All right.
Yeah, I'm listening.
Okay. So here's the question for you. If it's claimed that there is no ether, for the Michelson-Morley experiment, like Einstein claiming special relativity, then how is Michelson getting the exact sidereal rotation rate between Earth and space in his Michelson-Gale experiment of 1925?
I don't know. I've never heard of that experiment. I'd have to look into it.
Okay, so you're going to have to look that one up too. But see, here's a big.
I would bet that it probably doesn't overturn special relativity, though.
Yeah, well, you're going to have to look at it first.
Because, I mean, if it did, I don't think physicists would be using special relativity. If anything, it overturned it.
That's why they don't mention the Michelson-Gale experiment. You won't find that in your college textbook.
They might not be mentioning it because it isn't really relevant to modern physics. That could
it's
also
not relevant? Okay. So then the Sagnac experiment isn't relevant because that copied the Sagnac experiment. You want to go on to another topic? You don't seem to be well equipped to handle.
Well, no, because I'm reading on the
well, you can't study it now. I mean,
I'm not studying it. I'm reading on it because that's what I do in discussions when we have technology at our fingertips.
This is a debate.
But you also said that like general relativity contradicts special relativity. I think that's just patently false. General relativity is a generalization of the same thing that special relativity. Like special relativity and general relativity are the same theory, just described in two different manifolds. Whereas special relativity, you use a Minkowski space. In general relativity, you use, I believe it's a form of neo-Lorentzian manifold. I think they're called Riemannian manifolds or pseudo-Riemannian manifolds that can be curved, that can be irregular. That's really the only difference between them is the type of manifolds that we're utilizing to describe.
Well, the big difference is that special relativity has to have an inertial frame without gravity and inertial forces. Do you know of any in the universe?
An inertial frame of reference?
An inertial frame where there's no gravity and no inertial forces.
Yeah, an inertial frame of reference.
No, I'm not talking about inertial frame of reference. I'm talking about
that would be special.
An inertial frame that has no gravity and no inertial forces. Do you know of any in the universe?
Yeah, that would be an inertial frame of reference. I don't think we need to have those.
We don't need to have them, so it's all theoretical.
Well, of course it's theoretical. It's a special theory of general relativity.
The general theory of relativity. The general theory of relativity only deals with non-inertial frames.
Because it doesn't use inertial motion. It uses geodesic motion because of the structure of the manifold. It doesn't make any difference what
kind of motion it uses. It either has gravity or it doesn't.
That's one of the main differences between special relativity and general relativity. It's the difference between inertial motion and geodesic motion.
Yeah, the reason you have geophysical motion is because of gravity. Okay.
Well, yeah,
special relativity doesn't have gravity.
Yeah, because it's not curved manifolds, whereas in general relativity
we are. Manifolds doesn't make any difference. The reason you have a curved manifold is because you have gravity.
Yeah, that's how we describe gravity.
So one theory doesn't have gravity. The other theory does have gravity. That's the point. Okay,
but they don't contradict.
You got two different theories there. Okay.
Well, they're actually the same theory, just described on two different manifolds.
No. You can't, if one theory doesn't have gravity and the other does, then you don't have the same theory. You see, you're told that they're the same theory.
Well, it's because
here's what happens when you have gravity in general relativity. When you have gravity, the speed of light is not constant.
The speed of light is constant in general relativity. In fact, it is in Einstein's field.
No, it is not.
Wait, so does the speed of light appear in Einstein's field equations? Does C appear in Einstein's field equations?
Yeah, but it's not constant.
Okay, but if it wasn't constant, general relativity wouldn't work. Those equations wouldn't work. We've provided exact solutions to them. The Schwarzschild metric.
Yeah, if you confine it just to a heliocentric view and you exclude the rest of the universe, yeah, you can have that kind of Newtonian universe.
This isn't Newtonian. This would be Einsteinian.
No, you can have G equals A pi tau and F equals ma, and you could join them together in a system. But here's the crux of the issue is if you add the rest of the universe, Einstein has to say that the universe can go around a fixed Earth in one day. Do you agree with that or not?
Wait, what?
If you believe in general relativity, you have to agree that the Earth can be fixed and the universe rotate around it on a daily basis. Do you agree with that or not?
Well, that would be special relativity. That
has nothing to do with special relativity.
Well, it does. Just like with the example I mentioned earlier, you're essentially asking me, is there a difference between a car moving past a pole at 60 miles an hour with the pole stationary, or the car being stationary and the pole moving past it at 60 miles an hour.
Special
There's
relativity.
no mathematical difference between those two.
Yeah,
we could
that's
do the
special
same thing with the
relativity.
Earth moving in the universe or the universe moving around the Earth. The fact that the math stays the same doesn't mean that the other one is true. We still know, and like in the first scenario, the hypothetical, we still know the car is the one that's moving. We still know that the Earth is the one that's moving.
Yeah. So how do you know that the universe is the one that isn't moving, the Earth is?
Because the universe isn't a thing that can move.
How do you know that?
Because the universe isn't an object like the Earth.
How do you know that?
Because of cosmology and our understanding of space-time reality.
From where?
From science, from modern theoretical cosmology.
No, I'll tell you where you got it from. You got it from Edwin Hubble, who, when he looked at the redshift of the galaxies and saw them all with redshift and no blue shifts, he knew that the Earth was in the center of the universe. And he says so in his 1937 book, The Observational Approach to Cosmology. He didn't like that. So what he created was a balloon universe just with the surface. And he put all the galaxies on the surface. And then he started to blow that balloon up. And as all the galaxies separated from one another, they saw a redshift from each galaxy. That's how you got the Big Bang Theory. Okay.
Yeah, and the numerous other observations.
You proved anything about an expanding universe.
Well, yeah, we have. Well, science doesn't prove things, but the expansion of space-time is experimentally verified.
By
In fact,
what?
it's given by Hubble's observations.
Hubble
And by also by general relativity. See, this is the big thing. General relativity, actually, it would not work if space-time was static. It wouldn't work. And at that time, Einstein, all of them, they believed that space-time was static. It didn't expand. It didn't contract. General relativity, it didn't work. So the universe either had to be expanding or potentially contracting, but most would have said it had to be expanding. This was in 1915. This general relativity was confirmed in 1917. And then we actually observed the expansion of space-time in 1929. So there's corroboration there indicating that this is an actual observation that we're making.
No, actually what it is what I just said it was. It was he didn't want the Earth in the center, and then he created his expanding universe.
I don't think Edwin Hubble really cared where the Earth was at, and whether what his personal opinions on where the Earth would have been at or is at are completely irrelevant to the observations that he made.
No, they're not, because it shows the motivation of why he created his expanding universe. Go read his book.
He didn't create it.
He says about a dozen times in his book he says it a dozen times in his book that we can't have an Earth in the center of the universe. So what are we going to do? The only thing we can do is create a balloon surface and put all the galaxies on it and have it expand. That was his option.
Well, that was his observation, an observation we've corroborated probably hundreds of times since 1929. We've literally observed redshift. Numerous people have observed redshift.
Redshift does not prove that the Earth is expanding. There's about 60 explanations for redshift.
Does actually demonstrate that. And the reason that we know it demonstrates it is because the redness is directly proportionate to the distance. That means that physical objects aren't moving in space-time. Space-time itself is growing between the objects.
No, all it means is one galaxy is further away from the other. It doesn't mean there's any expansion.
Yeah, but the further away the galaxy is, the redder it is.
So what?
Buddy, how would you expect that means that space is growing between the two points?
No, it doesn't. No, I can place one object near me and another object farther away from me, and they're both going to give me redshift. That doesn't mean the system is expanding.
Do you know what causes what causes light to redshift in galactic redshift?
It could be a lot of things. There's 60 different explanations out there for redshift. You're picking the one that you like.
I've heard of one, and that's the one that the whole of modern physics since the 1920s has gone with.
Yeah, because they don't want an Earth-centered universe. That's why.
I don't really think physicists care if the Earth is literally at the center of the universe or not. I think they just care about what the
well, go read their literature and you'll find out.
I've read their literature. And
I don't think you have.
Redshift is for the audience's sake. Redshift is the result of a light wave being stretched, and this can happen like you can picture the Doppler effect with sound. As a train is coming towards you, the pitch might go up. As it moves away from you, the pitch goes down. It's the same effect, but with light versus sound. So the normal thought is, oh, well, the galaxies are moving away from us. The reason we know that's not the case is because the further away the galaxies are, the redder they appear, which means the further away they are, the more redshifted the light is, which means that the further away galaxies get, the faster that they're moving, or seemingly. The redshift is directly proportionate to the distance. Well, that actually doesn't tell us that the galaxies themselves are moving. It tells us that the space between us and the galaxies is expanding. The more space you have, the more space there is to expand. The faster the galaxy will move away from you, the more redshifted its light is. This has been experimentally confirmed
that's one
since it was first discovered in 1929 by Edwin Hubble. This is a part of the standard model of cosmology. You might not accept it. I'm not a professional. I've done many lectures by professionals on the subject. I've read their textbooks. I feel comfortable being within the framework of the consensus of modern cosmology.
Well, if you knew anything about the consensus, you would know that there's a lot of disagreement out there about redshift, which you don't seem to know.
There's not. Not amongst reputed cosmologists. I would say there probably isn't.
Yeah, you ask any cosmologist who's going to be honest with you, and he'll tell you that there's a lot of different explanations for redshift.
I have actually
it's
asked.
Not just because something is being stretched. There could be dust in the. That's what Hubble first thought. That there's cosmic dust in there that is slowing down the speed of the light, and if it slows down, it's going to go to the redshift. Okay, that was his first explanation.
And then he ruled that out. And it was the redshift proportionate to the distance.
Because he had to have his balloon universe to get
away. No, it's
center.
Just that's what he observed. And the universe isn't a balloon. Like the universe doesn't have a shape.
Go read his book. You ought to read his book first to find out what you're talking about.
Okay? Well, I know what I'm
in the book. About. He says that he sees the Earth-centered universe because of the redshift. You don't want to admit that because you don't like it. Go read the book first and then find out.
That's just not what's being said.
Oh, yeah. Well,
it's not what the experiments tell us.
Yeah, you're just like all the other ones. They come in here and they think they know everything.
I do not know everything. I am far from an expert on this.
Obviously, you don't know enough about Hubble because he said that instead of having an Earth-centered universe, we're going to have a balloon universe. But the redshift can support both of them. So you have no proof.
I think that's you interpolating your particular explanation.
No, these are his exact words. I write them in my book. You want me to read it for you? Would you like me to read?
Well, I would rather read it myself, but I'm probably not going to do that.
Well, then why don't you go do that? We'll move on to another topic.
What Hubble personally believes is not relevant to the science, the experiments that have been confirmed.
You just said he's the one that formulated it in 1929.
Yes, and we've also confirmed it literally hundreds of times since then in hundreds of ways.
Oh, so it wasn't based on what he said in 1929. So make up your mind.
It was based on what he observed, not what he said.
Well, what he observed is written in his 1937 book, The Observational Approach to Cosmology.
Einstein put in a fudge factor into general relativity because he didn't like that it showed that space-time would have had to have been expanding. But that didn't matter. We still now know that space-time is, in fact, expanding. So it doesn't matter.
No, you don't
all
know
throughout
that.
history, scientists tried to fudge the science because it didn't fit their personal views. But all of that ended up going away because the actual people who wanted to raw science decided to say, no, this is what we're going to go with.
No, they didn't. As a matter of fact, Hawking in his 2010 book, The Grand Design, says that the redshift that Hubble saw all around him would put the Earth in the center of the universe. Hawking himself.
Yeah, and I actually addressed that. I actually addressed that, and that has to do with the fact of that the expansion of space-time is a metric expansion of its scale, i.e., you would look like you're at the center of the universe from literally any point in the universe, because it is outward that you're looking from that point, and so you're going to see everything expanding. So we could go to the other side of the Milky Way galaxy, 70,000 light years away, and it will look like it's the center of the universe.
Yeah, I understand.
I.e., there is no actual center of the universe.
Yeah, I understand.
That's not explaining it away. That's actually what Einstein.
Because there's another explanation to it. The other explanation
is
the Earth is actually in the center of the universe. That's an explanation you don't like.
How come that then if we were to go 70,000, if we were to go 2.5 million light years away to the Andromeda galaxy, it would look like we're at the center of the universe.
You don't know that because you've never been there.
Yeah, we do. Okay? We know that because of the metric expansion.
You're just theorizing that what you would see on Andromeda galaxy. That's all.
No, we know that's what we would observe because of the metric expansion.
You don't know that that's what you would observe because you've never been there.
We do because of the metric expansion of space-time. which has been
No,
thoroughly
because
confirmed.
and where'd you get that from? You got that from the
Observations,
And where'd you get that from?
actual
The
observations.
observation of Redshift. And where'd you get that
Yeah,
from?
yeah.
You got it from Hubble. So it all goes back to Hubble.
Well, it's
And
not
Hubble
that
said either the Earth is in the center or you have an expanding universe.
you seem to be
Take one or
laboring
the
under
other.
the delusion that Hubble just like randomly pulled the universe is expanding out of his ass. He didn't. If he did, we wouldn't have confirmed those
No,
same
I didn't say he
experiments
pulled it out
hundreds
of his
times
ass.
over.
I said that he said this is how we get out of an Earth-centered universe. We
That's-
create a blue
no.
universe. I didn't say he pulled it out of his ass.
Well, it seems to me that you're arguing that his observation of redshift isn't something we've actually observed when it is.
It isn't, because you can't prove it.
So then how have we, well, science doesn't prove anything. Like you can't prove that
Well, so
electrons
then why are you
orbit
trying to
the
prove it then?
nucleus of an atom. I'm not trying to prove it. I'm saying this is what we have observed numerous times.
No,
If it wasn't something that happens in
observing
reality,
something
why would we observe it?
Observing something requires interpretation. Interpretation requires a basis for making the interpretation. So it's
Well,
not
that's
just
basic
observation.
philosophy.
You're acting as if we see a balloon universe out there. You don't. All you see is light, redshifted. That's all you see.
Getting redshifted because of space-time is
No,
expanding.
we don't know that.
Well,
You
we
think
do.
you know
because of
why
the
it's redshifted, but you don't know that.
Well, we do. It's because of the metric expansion of space-time.
You can just keep repeating yourself. It's not going to prove it anymore.
So I have a question. If you went to any major institution on this planet, Oxford, Cambridge, Harvard, Yale, Stanford, and asked anybody in the astrophysics and cosmology department, is space-time undergoing a metric expansion of its scale? How many do you think would say no, and how many do you think would say yes?
Most of them would say yes.
Okay, so why do you think that is? Why do you think that the guys with the PhDs who have spent decades of their life studying this and researching this would agree with me and not you?
Well, because if you put the Earth in the center of the universe, that means somebody had to put it there. Because it's
No, not
gonna happen
necessarily.
by
It could have
time
just
it's
happened. It could have just happened by chance. You don't know that.
An Earth in the center of the universe? Come on, who are you fooling?
Well, so let's put it this way: if there was a planet at the center of the universe, and that just happened by chance, and life developed on that planet, wouldn't they then say, "Hey, look, we're at the center of the universe"?
Yeah, and that would be a lot
Okay, so then
harder.
it
would be
could
a lot-
happen without
Yeah.
a god. You don't
Yeah,
need.
I'll give a
god
remote
or,
possibility that could happen.
Okay, great. So
And
then
if it
that,
did-
even if we granted that the Earth is at the center of the universe, that means nothing other than that. Hey, the Earth is at the center of the universe.
No,
I can
no,
do
no,
that.
no,
It's
no.
just
Let's
the
not be
case.
naive. It means that the chances of us saying that there's a designer out there who put it in the center is a lot greater than somebody who put it out in the remote recesses of space with no signpost saying here you are. Okay. I think anybody with logical sense is going to admit that.
But you yourself just conceded that it's possible that there could just be a planet that happened to be at the center of the universe and life developed
It's
on that
also
planet.
possible the sun doesn't come up tomorrow. Okay. It's a remote possibility.
Is it physically possible? Yeah, it is.
Yeah, it is physically possible because I believe it is physically possible that we are in the center. But
Yeah, it
if I
doesn't
went
violate-
and asked
doesn't violate
anybody
it.
at Cambridge or Oxford or Harvard, do you think that the Earth is in the center of the universe? Well, no. I mean, can you prove it? Well, no. Well, then why do you believe it? Well, that's because philosophically it disagrees with me, with my whole understanding of the universe.
I
That's
would
what they
actually
tell me.
argue it's probably more a result of Occam's razor and just other, experiments that we've done confirming the metric expansion of space-time.
If you want to use Occam's
Thereby,
razor,
you're going to observe space-time expanding outward from a center, regardless of where you're at. So it's always going to look like you're in the center.
no, actually the simplest version is to have a static universe that's rotating around a fixed Earth so that you don't have to have an expansion.
Occam's
Because
razor.
where are you going to get the energy for it? You're going to create dark energy. You're going to create dark matter. You're going to do away with the horizon problem
Occam's
because now you have
razor-
space expanding beyond the speed of light. You've got
Occam's
so
razor.
many problems with an expanding universe that you don't have with an Earth-centered universe where the universe is rotating around it on a daily basis. That's very simple.
Occam's razor doesn't state we go with the explanation that's the most simple. It states that we go with the explanation out of all the explanations that makes the least amount of assumptions while still explaining everything that we're trying to explain.
All right,
and
well, you
retaining
tell me
all
what
of the
assumption I'm
observations that we've
making.
made.
Tell me what assumption I'm making that won't allow a geocentric universe to work.
That space-time isn't expanding.
Excuse me?
That space-time isn't expanding.
Okay, yours is expanding, mine's rotating. What's the difference? They're both moving.
Well, there's a difference between linear momentum and angular momentum. Yeah.
It's still movement. I mean, what you want
Yeah, but
Occam's
there's
razor to be the judge.
so are you saying there's no difference between me throwing a baseball in a straight line and me throwing it and it curves? There's definitely a difference, i.e.
Oh yeah, yeah, we both agree that there's a difference, but I'm talking about movement. You're trying to use Occam's razor to say that my system is somehow complicated or doesn't fit the paramount
Well, it's because it is.
paradigm or whatever. I don't know what you're talking about. Mine rotates, yours expands. What's basically the difference? One has linear, one has angular.
The difference would be we don't observe like an angular momentum, I guess you could say, to space-time. We observe, I don't know if I would say momentum, because when we're talking about space-time, it's hard, but it's just speaking simplistically,
you don't experience
we observe
any
a linear
expansion.
momentum. Yeah, we do.
You don't experience any linear expansion. All you do is see the stars go around you every night. That's angular momentum.
Well, no, when we observe distant galaxies, they're redshifted, and their level of the redshift.
Here we
is
go back to
proportional
redshift again. You're
Well,
trying
yeah,
to prove
because
that
that's what
redshift
the
is
data
only caused
says.
by expansion. You can't do that.
I must be honest here. You haven't really explained away this data or given a model that better predicts this and explains how we get what we see without an expansion of space-time.
You know, put a light through a prism. Why do you see red light? Because it moves slower than the blue light.
Well, yeah, that's because you're putting it through a medium, and different frequencies will move.
Exactly, and that's what Hubble's first explanation was. The dust in the universe is going to turn it to redshift.
But if you put light through a crystal, the redshift, the redness that you see doesn't change with the distance that you put the crystal away from you.
Oh, I agree.
So like I said, what Hubble noted was that, well, it's not just that they're redshifted. They're more redshifted the further away they are. In fact, it's directly proportional.
Yeah, but that doesn't prove anything.
So it can't be.
Because if you have a galaxy that's
science
not
doesn't prove
expanding,
anything. Hubble wasn't trying to prove anything.
If you have a galaxy that's not expanding, and then you put another galaxy farther away that's not expanding, and they both go through the dust of the universe, which one is going to have a greater redshift? The one that's further away.
Yeah, that's why would that be?
Because he has to go through more dust. His light's going to be refracted more.
But that shouldn't be the case.
No, it is the case.
It shouldn't be.
Well, you can have all kinds of inertial forces out there. As a matter of fact, the rotating universe gives you the inertial forces to make the light go redshifted.
But those kinds of forces wouldn't redshift light?
How do you know that?
Because that's not how electromagnetic radiation works.
Oh, really? You don't think electromagnetic radiation is affected by inertial forces and gravity?
It's not.
Electromagnetic radiation is not affected by gravity?
No.
The whole other reason for redshift is because of gravitational effects on light.
No.
Yes.
Well, I suppose because as light climbs out of a gravitational well, since it must necessarily move its c, it loses frequency. That's how it loses its energy rather than in momentum.
Yeah,
so I guess you would be correct. It would be redshifted, and we can observe that in gravitational lens.
Okay, so you're corrected.
I thought when you said that gravity affects light, you meant like the gravity can slow down light or do stuff like that.
Same difference, whether it's going linear or whether it's going up from a planet. The same difference is going to cause the redshift of a light. It's the same gravity.
Yeah, but we can differentiate between gravitational redshift and expansive redshift as a result of space-time.
Of course you can, because you've invented expansive redshift. You haven't invented gravitational
it's because
redshift. It's already there.
We get two different observations based on those.
No, you don't. You get the same kind of
redshift. We do. An object or light that's redshifting because of gravity just stays redshifted. Redshift as a result of the expansion of space-time is directly proportionate to its distance from us.
No.
Yeah, well, according to the experiments that we've run and confirmed time and again.
You can say the same thing about gravity. The farther the light is from the gravitational source, the more the effective redshift is going to be. So it's the same difference. I want to go back to some other stuff you said. We should get off of this because we're going nowhere with it.
I did actually want to comment really quick on when you mentioned the Sagnac effect. That doesn't show that light slows down. It shows that because of the motion of the apparatus, you have time dilation effects.
Yeah, I see. That's exactly the point. You guys throw in time dilation as if it's something proven.
Well,
you just throw
science
it
doesn't
in there,
prove
and that'll explain the experiment.
Why do you keep saying like prove things when I've never once stated that I'm even trying to? Like, science doesn't prove things.
Well, you just told me that the reason for the Sagnac effect is because of time dilation. Is that proven or not? Is it proven or not?
It's demonstrated by consistent experiments all showing
Demonstrated.
the
Yeah,
same
well, we
results,
can
and
demonstrate
their
that.
corroboration by the mathematical underpinnings of that.
Mathematics has nothing to do with it. Okay, you can
Wait,
put
whoa, mathematics has nothing to do with physics?
No, I didn't say that. I said the
Well, this is
mathematics has
physics.
nothing to do with the Sagnac effect. You can make the
Well, the
math look
Sagnac
real
effect
at
is
any
a
time you
physical
want
effect.
by
And
putting the right figures in there. Okay?
actually,
if
the
you
funny
put Lorenz's contraction formula in there, yeah, you're going to get time dilation. But who says the contraction formula is correct?
the funny thing is, you say that if this mouse would work, you say that math has nothing to do with the Sagnac effect?
No, I said you can put in
delta
the math
phi
to make
is
it
equivalent
work.
to 8 pi over lambda c by is that omega dot a. So the Sagnac effect is literally represented by a mathematical equation, my guy.
You can put math numbers to anything you want to make them work. That's what I'm saying.
Well, the math isn't put
The
into
theory behind it has to be correct first.
the math is utilized as a method for describing what we're observing in a
No,
consistent
this is what happens.
manner.
You go in there, you look at the experiment, and you say, no, it can't be that one light beam's going faster than the other. So we'll throw in time dilation to make them balance.
Well, that's
then
what
you
the
put
math
an equation to it. And then you put
That's-
an equation to it, and you go, oh, wow, look, we put an equation to our theory. We don't even know if
of
the
course,
theory is correct or not.
That's what. Well, a theory by definition corroborates consistently with reality. By
It
definition,
doesn't, because there's other explanations to the same empirical
a
evidence.
scientific theory is a well substantiated, rigorously tested, and repeatedly confirmed explanation of some observed phenomenon.
Yeah, by all the elephants in the room nodding their head and saying, yes, it must be this way, because the
Well, no,
opposite is having the
that's
Earth
what
in the
we've
center of the
defined it
universe.
as. You know that we get to pick what words mean, right? Humans get to pick what their language, the words in their languages mean. That's what a theory is. That's why we call it atomic theory,
Yeah, and here's
general
another
theory of
for you.
relativity, quantum
The
theory.
way to explain the Michelson-Morley experiment without using special relativity is that the Earth is in the center of the universe, it isn't moving. But see, you don't like that explanation.
Well, no, it's just that doesn't corroborate well with the observations that we make. And
What other
doesn't corroborate
observations?
with the math?
What
The
other observations?
expansion of space-time, special relativity, general
Come on,
relativity.
expansion of space-time, you can't use that to prove that the Earth isn't in the center of the universe, and you know it.
Well, we can because
What
it
else do you
shows
have?
that there isn't a center to the
What
universe.
other proof do you have?
Well, we're not talking about proof here. Again, science doesn't.
Oh, okay, what other evidence do you have then that the Earth can't be in the center of the universe?
I wouldn't say that the Earth can't be, just that we don't observe it to be, as far as it's the observations we've been capable of making are, mainly because the universe doesn't have a center.
And you know that by how?
The expansion of space-time. The universe will look like it's expanding outward from any point,
So
i.e.
now
any
you're
point
going
will
back
look
to
like
the same unproven thesis that you had.
But of
before.
course it's unproven.
Everything you
science doesn't
know
prove
is based on the supposed expansion of the universe, which you haven't proven.
Well, it's because science doesn't prove things. We haven't proven that electrons exist. They just
Well, then don't
consistently
talk about it
report.
then if you haven't proven it.
But
If it's
so
just a
science. So
theory
what you're
of
saying
yours-
is that we should just completely ignore science altogether.
No,
I should-
please
well-
don't caricature what I'm saying.
Well, but you said
I'm
that.
saying you should be open to both possibilities. If you want to see the empirical evidence fairly and not one-sidedly, then you should acknowledge that an Earth-centered universe can answer all the experimentations we've done just as well as your expanding universe can.
Should I give as much credence to the idea that two magnets will stick together because of magical fairies as I should to quantum electrodynamical effects?
First of all, you don't know what causes magnetism.
Yes, I
Second
do.
of all, I wouldn't believe in fairies either.
I know what
So-
causes
so
magnetism.
please
In
again,
fact, I
don't
know what causes
caricature me.
magnetism quite well. It's what essentially you get a magnetic field when you put an electric field in motion.
All right, then explain gravity to me, if you know so much.
Gravity is curvature in the geometry of space-time by
And
the
you know
presence
that
of
how?
mass energy.
You know that
General relativity.
Yeah, and you know general relativity is correct how?
Because Sir Arthur Eddington and Albert Einstein observed two stars that exist behind the sun. They exist. So if you got the sun, you've got the Earth. The stars exist behind the sun. We shouldn't be able to see them, but we did. We observed them out here because their light was bent by the gravity of the sun, indicating that
That
space-time
doesn't
curve.
prove general relativity.
Well, of course,
A lot
because
of theories
science
that
doesn't
believe
prove
light
things.
is affected by gravity long before general relativity came along.
Well, they didn't
Okay.
know. They didn't know what light was. prior to like
And
the
they still
very late
don't.
1800s.
And they still don't.
Light is electromagnetic radiation.
Oh, that you just put words on it. That's
but
all.
Okay, so if light isn't electromagnetic radiation, how can it be affected by electromagnetic field? Like how can we polarize it? It makes no sense.
Yeah, because we don't know whether light is a wave or a particle. That's why.
Well, the thing with that is that light is a wave, and it's always a wave. It's just that we can reduce that waviness down to certain standards of deviation. So like you would have sigma x by sigma p is what is it? It must be greater than or equal to what is it? H bar over 2.
Let's not get
the wave particle duality doesn't actually show that things behave as particles. It just shows that we can reduce the waviness down to a certain point.
Yeah, let me just tell you this. Nobody knows how gravity works. Nobody's figured it out yet.
Yeah, we do.
There's about 36 theories out there. Quantum loop gravity.
Wait, hold on. You do know that general relativity predicted that space-time was expanding, which has been observationally confirmed.
No,
it predicted the existence of black holes, which have been observationally confirmed.
Black holes can exist in any system.
Of gravitational lensing, which was observationally confirmed.
Wasn't confirmed either.
It predicted the existence of gravitational waves, which have been observationally confirmed.
No, they haven't
confirmed either. The precession of the orbit of Mercury, which we've observationally confirmed. Literally every prediction general relativity has made, general relativity has made is making. There has not been a single test that general relativity has been put to that it's failed, my guy.
Oh yes, it has.
Like what? What experiments?
Read about
what experiments?
Okay? Like for the perihelion of Mercury. Einstein started
precession of Mercury.
It's not the precession. It's the perihelion.
Perihelion is the closest point to the sun, I believe, because aphelion starts with an A, aphelion
actually,
away.
We're both correct. It is precession and perihelion. Einstein started with the figure that he needed, and he got there by fudging the numbers on the other side to make sure he got there. Okay.
But my question is,
about all this. You can read about it in my book.
If a theory doesn't accurately predict reality, then why are the things? So you've got some theory, and it says, well, if this is true, you should see these particular effects occurring. And you're saying that this isn't true. But
I'm not saying it isn't true. Mercury does have a perihelion precession. Okay? But saying that general relativity is the only explanation for it is total nonsense.
I'm not saying that general relativity is the only explanation. I don't think I said that once. I said that it is the best explanation.
Can we get back on the geocentric stuff? Okay? Can we get back on the you had your turn now. I want to go back to some things you said.
Yeah, go ahead.
All right. First of all, Jupiter's moons don't prove anything. Because even the geocentric
science doesn't prove things.
They all have local systems that allow the smaller body to go around the larger. There's only one place in which the entire universe is going to go around something smaller, and that's in the geocentric system. Everything else is going to work in its local gravitational frame. You're going to see solar systems with planets going around them, and that's exactly what we'd expect. Why? Because they're not the center of mass of the universe. That's why. There's only one place that's the center of mass of the universe. There's only one place that the universe can go around.
Hold on. Did you really just insinuate the Earth is the center of mass? The Earth that is 1.3 million times less massive than the Sun, which is like one octillionth or one. I can't even remember some astronomically large number, the mass of the Milky Way galaxy. There is no center of mass for the whole universe. Mass is.
Are you going to?
It's not homogeneously distributed, but it's not. How do I want to word this? It's not that mass is evenly distributed, but we know why mass is distributed the way that it is throughout space-time.
Yeah, you don't know squat. Okay.
If
you're going to stick with the Newtonian system, yeah.
I am not using
Newtonian. Are you going to interrupt me, or are you going to let me explain?
Well, please don't charge me with utilizing Newtonian mechanics when I'm utilizing the standard model of cosmology, which utilizes Einsteinian relativity, not Newtonian mechanics.
Einsteinian relativity, whether you like it or not, says the universe can go around a fixed Earth.
It could, but that doesn't mean that it is, in fact, happening.
Wait. You just said Einstein relativity won't allow it. I'm telling you that it does.
I didn't say that.
Huh?
I didn't say that. I just said it doesn't comport with it very well, as the Earth.
You said that Einstein relativity will exclude the Earth being the center of mass of the universe.
I didn't say that. In fact, I'm pretty sure I
Do you agree
clarified
with it then?
and even gave, is it possible? Yeah, it's possible, but does it comport? Is it the best model that comports with the observations?
Well, wait a minute. You're saying two different things. When we first started this a minute ago, you said, you're telling me that the Earth could be the center of the universe when the sun is so big and the universe is so big. And now you're telling me that it's a possibility. Which one is it?
I was talking about center of mass of the universe. That doesn't even make sense.
What do you think Einstein said?
The Milky Way is.
No, I'm not talking about the Milky Way. I'm talking about
God
what
knows
did
how many
Einstein say
times
about
more
the Earth
massive.
and the universe.
What did he say about the Earth and the universe? I don't really think he said all that much.
He said the Earth can be the center of mass for the rotating universe. That's what he said.
I don't think he said it could be the center of mass. I think he said that there's no difference between keeping the Earth fixed and moving everything around it, or the Earth moves
and
alongside.
What would be the difference then between that and the Earth being the center of mass? You tell me.
Well, you see, you keep saying center of mass. Can you tell me what the term center of mass means?
Center of gravity, center of mass. I think you know what they mean, don't you?
Yeah. So how could the Earth be the center of mass for the whole universe when there are things significantly more massive?
If the universe rotates, it has to rotate around a central point. And that point is determined by gravity.
Wouldn't that be the most massive object, which is definitely not the Earth?
No, center of mass doesn't have to be massive. The center of mass is just an ideal point. It can be anything.
The ideal point in a mass where that pole, that gravitational pole is centered either for one body or for a set of bodies. So the larger a mass is, so if we put a star that's 1,500 times the size of the sun close to the sun would no longer be the center of mass for the solar system. That new star would, because it's more massive and thereby curves space-time more intensely.
Exactly.
So if you want to say, could the Earth be the center of the universe? It could be. That doesn't seem to comport with what we observe. It could be. But when you say center of mass, that's where even larger problems come into play.
All right, let's have a rotating universe without the Earth in the center. Is that possible?
I'm sure under some senses it could be possible.
Okay,
I don't think that we observe that, but
if it's possible to have a center of mass for that rotating universe,
wait,
now put the Earth where that's.
You keep saying, well, if the Earth is at the center of the mass, are we like inside some massive pocket of like dark matter or something that's extending God knows how many light years out?
We have space, and we have stars that fill in that space, and we have what we call that sphere. What do you want to call it? That's the universe.
So how
thing rotates? What's it going to rotate around?
How could galaxies orbit the Earth when galaxies are significantly more massive than the Earth is?
Because you don't know your general relativity. That's why. That's why you're asking that question.
I have a feeling if I asked you what a tensor was, you probably couldn't tell me. But if you think I don't understand general relativity, you are entitled to that opinion.
Yeah, well, you're showing me that you don't. And I know what a tensor is, okay? But
cool.
the point here is Einstein, by the whole nature of relativity, has to allow for both systems. And he comes out and says, yeah, I have to.
Yeah, but
my theory can't tell you which one's correct.
Again, this would be special relativity.
Excuse me?
I said this wouldn't be general, it would be special.
No, because general relativity deals with gravity. Center of masses deal with gravity.
Yes, but
special relativity has nothing to do with gravity.
It wouldn't be the center of mass because the Earth isn't massive enough to attract all the other bodies in the universe.
Yeah, well, there's where you make your other mistake. Even Newton would say that's a mistake because the object does not have to be massive to be the center of mass.
The equivalence between
the center of mass
the Earth being at the center of the universe and everything moving around it, or the Earth just moving relative to other bodies, is the result of there being no preferred inertial frames of reference, which is what special relativity says. To give my example again, it's the same reason why there's no mathematical difference between a car moving past a post at 60 miles an hour and the post moving past the car at 60 miles an hour. Those are exactly the same. But that does not mean
but that's not solving our
car
problem.
that's the one that's moving.
I understand that. There's
So
no
when
inertial-
Einstein says that you could put the Earth at the center of the universe and have everything moving around it, he was appealing to one of the most fundamental tenets of not general relativity, but special relativity, namely that there is no preferred inertial frame of reference.
No, special
Yes.
relativity would never put the Earth in the center of the universe because then it would be a preferred inertial frame.
Not actually, no, not necessarily.
The center of mass does not move. The center of gravity does not move. That's why it's a
And
preferred
that's
inertial frame.
why special relativity also says that the Earth really isn't at the center. There isn't like
I know.
an actual
That's what he said
objective
before.
center.
That
Because
was
then
my
it
whole
would be a
thesis.
preferred frame.
That's what he said before in 1905. 1915 came when he had to add gravity in. Then everything changed. Then we did have a preferred inertial frame.
No, we
And
don't.
that was the Earth. That
No.
wasn't true in the special relativity.
The Earth is not a preferred frame of reference.
Well, if it's the center of the universe and doesn't move, it is the preferred inertial frame, and that's
Yeah,
what
and
general relativity allows.
there are no preferred frames of reference even in general relativity. General relativity says exactly the same thing.
No,
because
general
it's
relativity
really
says we can't
extension
prove which one is the preferred inertial frame. But
no,
there
it
can
says
be
that there is
one.
one because general relativity is a generalization of
Well, then,
special
sir,
relativity.
you need to
manifold.
read up on Einstein. You
I-
evidently don't know.
I've
Einstein.
actually read his relativity, the special and general theory that was like literally written by
Well, you
Einstein.
must have skipped over the part that said the Earth could be in the center and the universe rotating around it.
Well, no, I know exactly what you're talking about. That was when
Okay,
he was
and do you
describing.
know what else he said about that?
That was when he was
What-
describing, like I said, that there are no preferred inertial frames of reference. It would be no difference than me saying, yeah, that car could be going past the post at 60 miles an hour, or the car could be stationary and everything around it is moving past the car at
Yeah.
60 miles an hour. But that doesn't mean that the car is literally at the center of everything and everything's moving around it. It's a demonstration.
Of course it doesn't,
that
because you're
you can
dealing with
pick
cars
any
and
frame of
posts.
reference, and the measurements are going to be the same. And that gave rise to the invariance of the laws of physics in any frame of reference, which is another one of the fundamental tenets of special relativity.
Yeah, well, they all went by the wayside when he invented general relativity, sir. Okay, you ought to
Well,
know
it
that.
didn't, because general relativity is a generalization of the
Okay,
same
in
tenets
general
of special
relativity, does light
relativity
constant or
to
not?
curved manifolds.
In general relativity, is light constant or not?
Is light, of course, light is constant in special and general
Then
relativity.
you don't know your physics. You don't know general relativity.
Okay, so then
Is there
why?
ether in general relativity or not?
No, there's not an ether in special relativity.
Then
You
you
do
don't know
realize
the
that
general
if there was an ether, special relativity would be wrong, because then the ether
That's
would
exactly
be
right.
frame of
And
reference.
that's exactly
And that is
I said.
why Dr. William Lane Craig is a neo-Lorentzian, because he's an A theorist, and in order for the A theory of time to be true, you have to have a
I don't care about
preferred
what William
frame of
Lane Craig
reference.
says.
So,
I'm telling you
yeah.
what general relativity says. General relativity, Einstein took back the ether in 1920 for general relativity.
no, he didn't.
Yes, he
Okay,
did.
let me ask you, which of the tensor equations in his field equations represents the ether?
Which tensor equation?
Yes.
That's the Lorentz transform.
No, the Lorentz transformations aren't tensor equations.
Well, whatever tensor
that's
equation
linear algebra.
Einstein developed from that. Who cares?
Well, he developed.
I'm
developed
asking you a
several.
question. Do you believe that the light speed is constant in general relativity? You said yes. Do you believe that
course.
there's an ether in general relativity? You said no, and that's false. Do
Well,
you believe
and
that? Do you believe that material objects can travel faster than the speed of light in general relativity?
Well, no,
Yes
but
or no?
that's not general relativity. It tells us that, again, that's special relativity.
No,
and
that is not. You
give
don't
a
know
brief
your general relativity.
to give a brief explanation, if you have, I'm going to do this with pens because I don't think my arms are going to fit
No,
on screen.
I'm not going to go over
So
the same thing with
you
you.
have
I'm
you've
not
asked
gonna
me
go
not to,
over
you've
that
asked me not to,
again, okay?
you've asked me not to interrupt you, and I've been at least trying my hardest not to. So please, I just would ask for the same.
You're not very good.
You've got two axes here. You say you've got an x-axis and a y-axis. So the speed of light would be defined as a 45-degree angle out from these. As you begin to approach the speed of light, these axes begin to converge, so that at the speed of light, you just have that one axis. You actually lose the manifold that you're mapping things on, i.e., you couldn't go faster than the speed of light. To go faster than the speed of light, not only would they have to converge, they'd have to come back out and go negative, and the math would just be so far removed from what we observe in our reality that it just wouldn't make sense.
All right, this
That's
conversation is over.
special relativity, not
This
general
conversation's
relativity.
over. You obviously don't know general relativity. You're trying to.
I'm
make
by
math
no means an
make a
expert
point.
on it, but I have a pretty.
You're
I
not,
would argue
you're
a
not even close
decent
to
understanding of it.
Yeah. Then you need to go read up on it, sir, because you don't know it.
I mean, I can give Einstein's field equations just from memory. I mean, g mu nu plus lambda g mu nu is equal to 8 pi g over c to the fourth by t mu nu, and can in fact describe what each of those tensors represents, or tensor equations, I should say.
All it shows me is that you studied the equation pretty well, but you didn't study.
Well, of course,
theory.
That's literally what
General
you.
theory says light is not constant. There is an ether, a material object can go faster than the speed of light.
And I did study the equation.
So, you can read this little book here called Geocentrism.
When you study general relativity, you kind of have to study the equations because those are the physical descriptions.
Yeah, you have to study the
and in John Carroll's book, Space-Time and Geometry, An Introduction to General Relativity, he talks all about, you got to know what differential geometry, all that fancy math stuff. You literally can't do general relativity without the math.
Do you ever hear of Hans Thirring and Joseph Lenz?
Hans Theory?
Hans Thirring. Thirring. Hans.
I feel like that would probably be pronounced Hans Thirring, and no, I haven't heard of that.
Okay. Joseph Lenz, which was his confidant. You ever heard of him?
I have not.
Have you heard of Julian Barber and Bertotti?
The name Julian Barber rings a bell, but I'm probably not thinking of the person you're speaking of.
Barber and Bertotti wrote a famous paper showing how Einstein's field equations can be turned into a geocentric universe.
No, I have heard of that. I haven't looked into it myself, but there was oh God, who wrote the article? It wasn't Ethan Siegel. Oh my God, who was it? Maybe it was Paul Sutter. I don't know. There was somebody, a PhD astrophysicist, wrote an article about. I think it might have been Paul Sutter because I think I read it in Space.com. Anyway, and they went through. It's obviously very, very simplistic for a lay audience of why that doesn't work. I probably couldn't tell you why off the top of my head. I'd have to look it up. But you don't seem to like it when I look things up on the fly, so I'll respect you and not do that.
Yeah, obviously you haven't read their paper, so we'll move on.
Well, I would imagine if their papers were rigorous and peer-reviewed and actually overturned, they probably would have won a Nobel Prize for doing it.
Nobody overturned them.
Well, so then why is it not the standard model of physics then?
Because nobody wants it for the same reason I told you before.
Why do physicists not want it? Why do they care?
Because nobody wants the Earth to be in the center of the universe. That's
why. Why don't physicists want that? Why would physicists care?
Because it smacks too much of God. That's why.
Well, wait, hold on, my friend. You do realize that most physicists on the planet believe in a God? So why would they not want?
No, that's not true.
No, it is true. Now, the belief in God is less amongst scientists, especially physicists, than it is about the general population. But there are still slightly more physicists and just scientists in general that believe in God than that don't. That is a fact. I can cite.
That is not a fact.
I can cite from Pew Research Center.
I did the research from the Scientific American. 90% of the scientists out there, the big name scientists, are atheists.
Well, that would be big name scientists. That's not an accurate.
Yeah, well, they're the ones who make the movies and write the books and who we're talking about.
Well, no, actually, a lot of scientists that aren't big names teach in universities or doing research.
Yeah, and labs, 60% of those don't believe in God. So the odds are not great.
Actually, I know quite a few who are. I know quite a few who aren't, but there's a few out there that are. Yeah, definitely.
Yeah, well, I'm just telling you what I've read in the books from Stephen Hawking and all the other guys. They all say, well, no, that would make it look like a designer was behind it, put it in the center, because I can't explain it any other way that it got there. That's what their explanation is.
I don't think that's what they're saying, but like I said earlier, you are entitled to your own opinion.
Well, of course, we're all entitled to our opinion. Let me go back to a couple of other things you said, because I want to clear these up so there's no misunderstanding. You said that Kepler's model challenged Tycho because Tycho didn't have elliptical orbits. Well, there was a guy named Rinuccini who came along after Tycho and put elliptical orbits on Tycho's orbits, and everything turned out just like the Keplerian system. So again, showing the equality between the two systems.
It was actually all three of Kepler's laws that don't comport with a Tychonic model, and then Newton's laws of motion could be used to derive Kepler's laws, thoroughly corroborating the validity of both and describing aspects of physical reality.
They both stuck with the solar system and avoided the rest of the universe. That's the problem with both Kepler and Newton. That's what Mach came along and told us 200 years later, that you can't arbitrarily dismiss the rest of the universe in your equations to see what goes around what. Okay, that's what started Einstein on this whole kick.
We don't need to know what Sagittarius A star, the black hole at the center of the Milky Way galaxy, is doing to predict the orbit of the moon around the Earth.
No, but you need to know whether the universe can move or not. If you exclude it from moving in your equations, then you've made an assumption.
Well, that's because the equations aren't excluding anything. They just don't seem to indicate what you're concluding yourself.
No, the equations don't conclude anything. They're the numbers that you put onto your observations. And if your observation does not include the rest of the universe, then your equations are going to be faulty. That's why F equals ma doesn't work when they send satellites up.
It does.
No, it doesn't. They have to add in the centrifugal and the Coriolis force to make them work, to get to where they're supposed to be.
Yeah, like F equals ma, the actual equation is a little bit more than that, and it involves some calculus and taking derivatives and things of that nature. F equals ma is generally it's like if anybody's ever seen a depiction of, say, Schrodinger's equation, which is F equals ma for quantum mechanics, that you often see like H psi equals, what is it? H psi equals E psi, which is a rough generalization of a much more sophisticated equation. F equals ma is the same. E equals mc squared is the same. They're generalizations of those equations because it's just easier to, in a general sense, that's why we generalize them. It's easier to work with them.
Yeah.
But when you're actually like doing derivations of these equations, you don't work with the generalizations. You work with what the actual equations are.
In other words, you have to add in the inertial forces, centrifugal force, and Coriolis force, and Euler force. Now, why that's important is because when you have a rotating universe around a fixed Earth, the angular momentum of the rotating universe is going to create those very forces. So we don't have to add them into the equations. They're already there in a geocentric universe.
Well, first, I just wanted to say one thing. It's Euler, not Euler. It's pronounced Euler.
I'm sorry, Euler. Yeah.
And of course, those forces would have to be included into them. That's generally why we like to use special relativity, because it's an extension of, well, not just Newton's laws, but of just classical mechanics in general.
In other words, Newton had a defect that Einstein had to improve.
Oh, yeah, we all know that. Newton's.
Okay, so where did he get it from? He get it from the fact that he just had the solar system as his little
that's
mom.
Not what it is. It's mainly that one of the biggest issues was that Newton had two defects. He had number one with relativity, that he had space-time fixed and immutable, and we know space and time. Well, number one, they were separate and immutable. We now know they're combined in one manifold that can be bent and stretched and twisted and contorted. So it's Newton is not wrong. It's just his Newtonian mechanics, which I guess you could include classical mechanics in there, is an approximation of both relativity and then something like quantum mechanics for things that A, aren't moving close to the speed of light, and B, aren't really small. Yeah. So Newton was not wrong. He was on the right path. He just didn't have access to enough technology to make the observations that would have brought him to relativity.
Yeah. And what I'm saying to you is,
jumping into Q&A in just a minute, guys.
In his
right on.
Equations, then he would have not had a problem.
Well, we'll jump into it. Want to say thanks so much, everybody, for your questions. Our guests are linked in the description, so if you'd like to hear more from them, you can hear plenty more from our guests by clicking on those links below. Also, a couple links to after shows are also linked in the description. I think it's Crafty Keela is hosting one, in which I think they said that both of you, Leo and Dr. Robert, are invited, and then also they had said that in the other one, Speed of Sound of Gravity, they had also said that they're hosting an after show, which is linked in the description as well. And Marty Camijo says, yay, Leo. You got a fan out there, Leo. Mike Billars, thanks for your super chat, said, let's see. Wow, this debate is one facepalm short of a flat earther. Ooh, controversial. And Sunday Warship says, how does Dr. S account for the predictable annual meteor showers?
They're the same in the geocentric and heliocentric system. There's no difference.
Gotcha, thank you very much. And Cider and Port says, after show on Crafty Keela's channel, Leo, we want you on to chat if you're down. Link is sent to you on Twitter. Oh, okay, so Speed of Sound
Poggers.
Speed of Sound of Gravity said, after show on Speed of Sound of Gravity, can you check your email? I definitely got that for you, Speed of Sound, so that's in the description as well. El Spigato, thanks for your question, said, Dr. Sungenis, thank you for your patience, says, are there any recent models or diagrams for the geocentric universe that you could point us to help laypersons like me to understand how the thing you've described works?
Yeah, go to our website, journeytothecenteroftheuniverse.com. We have a flash drive that has over 60 animations of the geocentric universe, not just the solar system, geocentric universe or system, but the whole universe rotating. Everything that I talked about tonight is on that flash drive in animations, and we've done a lot of work to put those things together for you, so take advantage of it.
Thanks so much. And want to take a quick moment to remind you all, if you have not heard, actually, this is a new one, we are now on Audible and Amazon Music for our podcast. So this debate will eventually be in the podcast format. And want to let you know, folks, we are on virtually every major podcast. If you can't find us on your favorite podcast app, let us know. We will work hard to get on there for you. Next, El Spigato, we got that one. Oliver Catwell, thanks for your super chat, said, start 2021 on a positive note, do something nice for someone, give a random compliment, and hit that like button. Thanks, Oliver, for your support. Really do appreciate it. And Mike Billar says, could Dr. Sungenis please name a couple of the 60 possible reasons that he thinks redshift occurs?
I've already given several of them. Gravitation is one. Cosmic dust is another. The guy who did this was Sandage. What's his first name? Famous physicist. Sandage is his name. I forget his first name. He's the one that put the list together.
Gotcha. Thanks very much. And this question comes in from Maynard Saves, who says, Leo Phileas, the most brilliant Bobby Dazzler of them all. What is a Bobby Dazzler?
It's a Bobby Dazzler! If you watch The Curse of Oak Island, you know, Gary, you'll know it. For anybody out there in the audience.
Off to see it. Next, thank you for your super chat. Space Monkey says, Leo has a broken epistemology. We know the Bible is true, so start with the conclusion, Psalm 104, verse 5, then work to make the evidence fit. The Bible comes first, evidence second. Silly atheist. This has to be a troll because they spelled atheist wrong, but I don't know for sure.
That reeks of troll.
Okay, next up, El Spigato. Thank you for your question. Says, this is a stick up. Everybody summarize Hubble's teaching right now. So give a chance to Robert, and then we'll kick it over to Leo to explain, or I should say summarize, Hubble's teachings right now.
Yeah, I'll just repeat what I said before. Read Hubble's 1937 book, The Observational Approach to Cosmology. In there, about a half a dozen times, he says that the redshift puts the Earth in the center of the universe. He doesn't like that. So how do we get away from it? We create a balloon universe and put all the in creating a balloon universe, what you're doing is you're taking the center out, because a balloon doesn't have a center. It just has a surface. So if you put all the galaxies on the surface and you blow up the galaxy and have it expand, all the galaxies are going to move away from one another, and they're each going to see a redshift from every other galaxy. So that's how he explained redshift from a non-geocentric viewpoint. And then, what's his name? Lemaitre came along and said, well, if we have an expanding universe, then what happens if we reverse it? Well, we go back to a cosmic egg. And he believed, he basically invented the Big Bang Theory. And then, what's his name? Eddington came along and said, well, he didn't believe in the cosmic egg, so they had a little tussle between themselves. And then Fred Hoyle came along and put the words Big Bang onto Lemaitre's theory, and that's how we got the Big Bang Theory. And from that, we had Penzias and Wilson come along, 1963, who claimed that the cosmic microwave background radiation was the remnants of the Big Bang. But then we had some other things happen, and this is what our movie is all about. The principle, they sent up 3 probes, one in 1990, one in 2001, and one in 2009. The Kobe probe, the WMAP probe, and the Planck probe, and they all came back with evidence that the Earth was in the center of the universe. Why? Well, because the cosmic microwave radiation wasn't isotropic and homogeneous. It was anisotropic and inhomogeneous. And it was aligned with the ecliptic of the Sun-Earth, which they call the axis of evil. And that has not been disproven because they had 3 space probes up within 20 years showing that it existed. So there's another piece of evidence. So the Big Bang Theory is on its way out. I give it another 25, 30 years, and it's going to go kaput.
Thank you very much. And Leo.
So I don't know what the asker meant by, excuse me, Hubble's teachings. But what Hubble observed, independent of his own personal opinions, whatever they may have been, was that distant galaxies, this isn't galaxies close to us, this is very distant galaxies, appear redshifted. Their light is redshifted. And he thought, well, that's rather interesting. Maybe, it could be like Robert said, it could be due to cosmic dust. But then he noted, well, wait, hold on here. The further away they are, the redder they appear, and it's directly proportionate. There's a linear relationship there. So it seems to me, he said, that the galaxies themselves are not moving, because once we start getting further and further out, galaxies are moving at speeds that galaxies just wouldn't be capable of moving at. It seems as though the space between us and the galaxies is expanding, and naturally, the further away a galaxy is, the faster it's going to move away from us, because the more space there is in between us to expand. Similarly, if you put a bunch of dots on a balloon and blow up the balloon, you take 2 dots that are close together, they'll move apart pretty slowly. If you take 2 dots that are further apart, they'll stretch apart more quickly because there's more balloon to be stretched in between them. George Lemaitre came along and ended up developing the Big Bang model, like he said, which we don't really call it the Big Bang model. It's the lambda CDM model because it incorporates both dark matter and dark energy, lambda representing dark matter, and CDM standing for, or dark energy, and CDM standing for cold dark matter. The cosmic microwave background is essentially experimental confirmation of the Big Bang because it shows that the universe started out in a very hot, very dense state. The cosmic microwave background are the photons that are left over from the period of recombination, roughly 400-ish thousand years after the Big Bang, when photons decoupled from matter and were capable of actually moving through space-time without being absorbed. Prior to that, the universe was too dense, too hot. It was a plasma. It's sort of a hot soup between protons, electrons, and photons bouncing off of them. So the universe expanded, cooled down, matter formed, hydrogen atoms, which is another reason we know the Big Bang happened, the abundance of hydrogen. And the one more thing I wanted to comment on is I actually have a link from Science magazine titled "It's Official, You're Lost in a Directionist Universe" from September 7th, 2016, that mentions the axis of evil and actually shows that no, there is no axis of evil.
Next up. Thank you very much.
Wow.
Got to jump to the next one. Mitchell says, question for Leo, can the brain waves or ear sound waves and the visual spectrum expand? If so, why can't the universe do the same and retain coherence?
I have no idea what they're even trying to ask. I have no idea what they're trying to ask.
I can read it one more time. It said, can the brain waves, ear, parentheses, sound waves, and the visual spectrum expand? If so, I think that he's saying like they can expand. So why is it that the universe can't expand and still retain its coherence as well?
When he says its coherence, I don't know that the universe is expanding.
Gotcha.
It's because of the stretching of those light waves that we know that the universe is expanding.
Thank you very much. Mike Billars, thanks for your question. He said it, quote, an Earth in the center of the universe. They're skeptical, but I guess we'll let you make your own decision out there, folks. Mike Billars is skeptical, though, and Michael Dresden, okay, that's another troll. Chad Eckert, thank you for your Super Chat said, "This isn't the Redshift you are looking for." Thank you very much. I love the Star Wars reference. Any Star Wars reference is good here. Luminiferous Ethan says, to the geocentrist, if Earth is at the center, why does the planet Mars retrograde do a loop in the sky over time? How does that work?
Well, if you can look at a geocentric animation that we have, the ones that I said, we have 60 animations on our flash drive. It'll have geocentric retrograde and heliocentric retrograde. And you'll see by very simple, just reversal of the Earth and the Sun, that the same retrograde is going to appear in the geocentric universe that appears in the heliocentric universe.
Gotcha, and thank you very much for your question. This one comes in from El Spigato. Says, I suspect Dr. Sun is a crypto flat earther. Everybody vote now. I don't know what crypto in this context means, but I think they're asking if you're a flat earther.
I gave that in the beginning of the program, I think, when I said flat earth is wrong. I wrote a 700-page book titled Flat Earth, Flat Wrong. But what I did say is it's not as easy to get to the right position as some people think that it is. And I gave the example of looking over the Lake Michigan and seeing the Chicago skyline. Yeah, it does drop 900 feet under the ground. And so how do you explain that? Well, do you explain it because, I'm sorry, on normal days, you can't see the Chicago skyline. On some days you can, especially in April and May. So why is that? Is the Earth flat? No, it's because of atmospheric aberration. Because of the temperature between the water and the air, it changes sufficiently enough to bend the light so that it appears that you can see the Chicago skyline. You can't get to that position unless you do your scientific homework. And that's why I'm saying it's a little hard to get to the position that the Earth isn't flat, a lot harder than some people think, although I'm not a flat earther and never have been.
Gotcha, thank you very much. Mike Billars says, Doctor, if I show you the source code to my working GPS receiver, which shows relativistic corrections, will your... They said... I think they're saying, will this make sense under your view? How do you explain this under your view?
Yeah, because the relativistic corrections that you're seeing are just the product of the Sagnac correction that they put into the GPS. You see, because they know that light does not travel the same speed east to west as it does west to east. So how do you compensate for that? There's a 50 nanosecond difference between the speed of light in one direction and the other. Well, you program the computer with a Sagnac correction, and then it comes out that the speed east to west and west to east is the same. But it's not because the light speed changed, it's because they changed the computer program to make it look like that. And that's why you get a relativistic effect.
Gotcha. Thank you very much. And thank you very much for your next question. This one coming in from Remnant Art, who says, Dr. Sungenis, I don't believe you. Science never proves anything. It develops models. Let's see. I'll give you a chance to, if you disagree or not, regarding whether or not science develops models, if you want a chance to respond.
Yeah. I think he's getting at a good point. Special relativity is a model of the universe. General relativity is a model. Geocentrism is a model. We see the empirical evidence, but we have to interpret it. And sometimes we interpret it based on our presuppositions, our biases, our prejudices, information that's not complete, information that is faulty. And so the model that we make from the empirical evidence that we see is going to be subject to all those little follies and foibles that we have in our minds about how do we interpret this evidence. Sometimes we hit it right, a lot of times we hit it wrong, okay? But each of us is going to make a model of what we interpret that evidence to be saying to us, but we may be wrong in interpretation.
You bet. Thanks very much. And thank you for your super chat from Nephilim Free. Says, thanks for all that you do. I appreciate your positivity, Neph. Thank you. And thanks everybody else for being so positive in the chat. We appreciate all your encouragement and we're excited about 2021. Next up, Daver, thanks for your question, said if everything in the universe is expanding, how could asteroids and meteorites crash into planets and moons? I think they're saying, like, if the universe is expanding so quickly, it would seem that they would never be able to make it to being, or I should say, if these, you could say, items or objects are expanding so quickly from each other, how could they ever make it to actually colliding with each other as they're moving through this expanding away space?
I'd like to add to that and say that if the universe is expanding, why don't we see our solar system expanding? Why don't we see our galaxies expanding? They're all the same size.
We'll give you
they were hundreds of years ago.
Just so we don't,
Okay.
let's give Leo a chance for both these objects as well as why it doesn't appear that our solar system is expanding. Leo,
can you reiterate the question?
Sure. So
I just want to make sure I understand it correctly.
They had said, if everything in the universe is expanding, how could asteroids and meteorites crash into planets and moons?
Well, everything in the universe isn't expanding. Space-time is expanding. It's undergoing a metric expansion of its scale that is only measurable over vast distances on the order of tens of millions of light years, if not hundreds of millions of light years. Objects in space-time are not expanding. Space-time is expanding, and since those objects exist in space-time, the space-time is carrying them with them. Like if I take a piece of paper and I drop it in a river, the paper actually technically isn't moving relative to the river. It's just being carried by the movement of the river.
Gotcha. Thanks for that. And then Cider and Port, thanks for your question, said, did this doctor just say we don't know how gravity works? I took an edible earlier, so it could be that it's playing with me. Let's see. So they're skeptical about your idea that regarding gravity.
Yeah. So Einstein's theory, where space is bent. First of all, that begs the question: if space is just space-time, then what's bending? That's number one.
Space-time.
But it's just a theory. Okay. Nobody knows why an apple falls to the earth. Newton thought he might have to do something with ether. We can tell you how fast it's going. And we can tell you what the escape velocity is, 9 meters per second. And we can tell you that the apple falls 32 feet per second, but we can't tell you why it falls. What is the mechanism that's pulling that apple or pushing that apple? We don't even know if it's a pull or a push. And there's all kinds of theories out there. There's hundreds of theories of gravity out there. Even quantum mechanics has its own theory of gravity, quantum loop gravity, and superstring theory, and all that kind of stuff, which goes entirely against Einstein's view of gravity. But you have to understand, these are all theories of what makes one object attracted to another, or what's pushing one object to another. Nobody knows. Nobody has proven what the real cause of gravity is.
Gotcha. And thanks so much for your question from Ray Callagher. Says, electromagnetism is literally caused by relativistic length contraction. I would be happy to explain this to both debaters anytime.
Well, I already know what he's talking about. He doesn't need to explain that to me.
Yeah, well, he would need to explain it to me, because relativity was not designed to answer Maxwell's equations. Maxwell's equations are still used today.
Of course.
Thank you.
He has two basic equations, and they both, one says one thing, the other says another thing. It tells us how an induction coil and a magnet work together, and they both have different equations. Well, how can that be? All you're doing is moving an induction coil around a magnet, and then you're moving the magnet around the induction coil, but you have two different equations for that? Yeah, that's the way nature works. Why? Because it's not relativistic. It's absolutistic. That's the whole thing that Maxwell gave us. Einstein didn't like that, so he tried to relativize Maxwell's equations. Because if we're going to have relativity explain the Michelson-Morley experiment, well, it better darn sure explain Maxwell's equations too. You see, the deeper they dug their hole, the further they fell into it. And until today, Einstein is, his own theory contradicted his previous theory. General relativity contradicted special relativity, because special relativity went off the wrong track right from the get-go.
Gotcha. Thank you very much. This one coming in from El Spaghetto says, this is another stick-up. Are either of you selling a book? Please answer.
I have plenty to sell. Here's one for you. Geocentrism, geocentrism for dumpskis and smart kids.
Thank you. And El Spagato strikes again, says G-Man wins. Everybody pack up and go home. G-Man's one of our regular debaters. Although we haven't had, it's been a long time since we've had G-Man on. So G-Man, we hope you're doing well. Leo says, you know those balancing birds? Dr. Robert is likening the universe to that, where the Earth is the bird beak. Center of mass doesn't have to be massive.
That's right. That's why I told Leo that you could have the center of mass for a universe without having anything in the center. Same difference. You could put the Earth there, have nothing there. The universe is going to rotate around the center of mass.
Gotcha. And this one comes in from Cider and Port said, Dr. Robert, where did you receive your doctorate?
Calamus International University. I read
Thank you.
700-page dissertation over about 3 years. Got my PhD in 2006.
Thank you very much. Mike Billars, thanks for your question. Said, Leo, you know those balancing... Oh, we got that. Decepticons Forever says, let's see. Just trolling. And Remnant Art, thanks for your question. Says, Dr. Non-Genius... Oh, you got quite the skeptic out there, Robert. Let's see. They say, you are... we got a lot of trolls. They say you are coming across like very defensive when Leo gets into specifics. This is typical for conspiracy types. Is this the case, Robert? Do you think you're getting defensive, or do you think that you're not?
I think it's just a stereotype. Thank you.
Thank you. Mike Billars, thanks for your question, said, so your argument is, quote, all science that disagrees with me is conspiracy by atheists, and all science that blurs into my view is right because of God.
No.
Thanks, Mike Billars, as well, for saying, let's see, Robert, does your belief in God hinge on geocentrism? For example, if heliocentrism was proven to be true, would you still be a theist?
Yes, I would. God can make the universe any way he wants.
Gotcha. Thanks so much. Space Monkey, thanks for your question, said, for Dr. Sungenis, if the Bible instead had poetic descriptions of heliocentrism, would you still believe in geocentrism? If no, what then would you do with all of your evidence for geocentrism?
Well, see, that assumes that poetry in the Bible is fictional. It's not. Most of the quotes in the New Testament to verify New Testament truth come from the Psalms, which are all poetic. The only thing about poetry is it's put in rhythmic language with cadence and rhymes and things like that, but it doesn't mean it has any less truth than something written in prose.
Gotcha, and thank you for your question. This one coming in from Mike Billar says, well, the doctor is right. I guess I just deny geocentrism because I hate God and I love my sin. Thanks for your honesty, Mike. And
yeah,
next
there are
up,
some out there that do that, I'll admit.
Next up, El Spagato says, honest question, who is they? I think they're meaning like if anybody refer to people as like they like don't want the truth out or something like that, or they don't, maybe it was the idea. I'm not exactly sure who they is either. You guys know what that context is?
I can't remember now.
I do not.
Gotcha. And this one comes in from, I think I had read, yeah, we read Space Monkeys, thanks for that. We read Mike, let's see, Andreas Elda, thank you, said, Dr. S, how does Alpha Centauri manage to travel a 25 light-year cycle every day? Hint, they say very much faster than the speed of light.
Oh yeah, anything past Saturn is going to go beyond C. Because of Einstein's general relativity theory. That's what we spent the whole time basically on in this debate. Einstein says because of relativity, the Earth is fixed and the universe is rotating around it, or the Earth is rotating under a fixed universe. Take your pick. And if the universe is rotating around a fixed Earth, obviously then Einstein agrees that material objects in light have to go faster than C. C is
Gotcha.
only for light speed that's near the Earth or on the Earth. That's where they've measured it. And I would agree that light near the Earth or on the Earth is 186,000 miles per second.
Gotcha.
I just
And
wanted to say really, really quickly that if the speed of light is not constant, the fundamental constants that govern pretty much all of reality and like almost all of quantum mechanics would also be wrong. And those are confirmed to many more decimal places than either general or special relativity.
gotcha.
Well,
And thank you.
talk to Einstein about that one.
Thank you for your question. Mike Billar says, let's see. Can we all take a moment and appreciate how devilishly good-looking James is? Like I said, we've got a lot of trolls. James, is that a new blazer? No, it's the same blazer. I'm telling you guys. Goodwill, any sort of thrift shop, you can get men's blazers for like $5 to $8. It's tremendous.
James,
And
I haven't been able to see your picture here all night. I just see your name.
oh, that's right. I've only got, because I'm on the road. I am currently, if you see the video after, it looks like I'm in a bunker. I don't have both of my cameras, but I'm wearing a blazer and my just a tee underneath. But I am, yes, I do love blazers. There's no doubt about it. And Silver Harlow, thank you for your question. Said, Dr. Robert, what novel testable predictions can your model make that might falsify it?
None that I know of. We've been through them all. We've passed every one.
Gotcha. And Mike Bellars, thank you for your super chat, says, I guess we all just took edibles. Gotcha. Well, not me. Next, Animated Effigy, thank you for yours, says, Dr. Religious Studies, here's the one who wants to impose his beliefs on science. We're not even the center of the galaxy. How can we be the center of the universe? So we'll give you a chance to rebut any one of those points if you'd like, Robert.
Well, yeah, obviously we're not the center of the galaxy, but the galaxy does rotate around us. I mean, the galaxy could rotate around us if we're on one of the outward spiral arms of the Milky Way. It doesn't make any difference. Obviously, we don't want to be in the center of the Milky Way, otherwise we'd be burning up. And what was the other thing? Doctor of Religious Studies. Well, religion and science, at some points, they converge, they overlap. And we're talking about one of the places where they do overlap. This was a religious issue back in the 1600s with Galileo, as much as it was a science issue. With people that came before, they had a philosophical preference for either a geocentric or a heliocentric universe. They speak about that. So these, again, are places where the two sciences or two ideologies converge, and we have to discuss them at those points.
You got it. And thank you for your question. This one coming in from Animate. Oh, I think we got that one. Let me go to this next one. This one is from Dean Kruger, who said, where is Dr. Sungenis published?
You can go to robertsungenis.org or .com or .net. So that's my first and last name, .com. Or you can go to journeytothecenteroftheuniverse.com.
Thank you very much. And want to remind you folks, few things. One, our guests are both linked in the description. So if you would like to learn more about them or about their ideas, you can go to those links and read or hear plenty more. And also, we have those after show links, which are in the description as well. Also, we will be right back. We're going to take a short intermission, and then I will be back with some epic new announcements. I don't know if you guys heard the huge news today, but we are thrilled that we have reached our Kickstarter goal, and we are creating a stretch goal. So we are going beyond that original goal, and I would love to hear your guys' ideas as I'm seeking feedback on like what kind of stretch goal might we do, stuff like that. And so do stick around. We will be back in a few minutes, but first I want to say thanks again to our guests, Robert and Leo. It's been a true pleasure. Thank you so much for hanging out with us tonight and making your case on modern day debate tonight.
Great. My pleasure. Thank you.
Thank you. Follow me on Twitter, peeps.
Thanks so much. And as mentioned, I will be right back, folks. Thanks so much. Ladies and gentlemen, stoked to mention, this is epic news, you guys. We are thrilled, you guys. We are stoked about the fact that we have reached our Kickstarter goal. Despite, I would say, it's been so many of you. I want to say thank you so much. You've been so supportive. You've been so positive. Even when we were like sitting at like, I don't know, $8, you know, when we opened, it was like, you know, it was like kind of trickling in. And so I want to say thank you so much for those of you who have been positive despite that. One of the biggest lessons I've learned in my life in different domains like college football and other things is that one of the best qualities you can have is believing in something even when it seems hopeless. Really, like that's where you're just like, oh my gosh, like I don't think we can win this anymore. And so I do really want to say we totally appreciate you guys for being super encouraging, super positive. That Kickstarter is in the description. You can still give to it. I want to show you guys a few things for that. As we are pumped, as we're not stopping. In fact, this is, you know, we're thrilled. I mean, we may still do, as you're seeing on the screen, that's me, Steven Steen, and T-Jump. We may still do this car wash in January to raise extra funds to throw into the Kickstarter. Look at Tom. He looks terrific. He loves holding the hose there. Look at him. He's a terrific guy. But we are very excited. Got to let you know about a few things. One is I am blown away by the fact that we made that goal. We're absolutely thrilled. So this debate you're seeing on the screen will be live next Friday, January 8th. The Kickstarter is still open, so you can still watch it live. It's just $3. Which, Mitchell, thank you for your $3 super chat that you just sent right now. Really appreciate it. Is that all you have to do is if you go to the Kickstarter, which is linked in the description, and which I will throw it in the live chat here in just a moment. Basically, the way it works is that, you guys, this is honestly too cool. You don't even have to create an account. If you want, you can just go into this Kickstarter link, and if you just sign in with Facebook, you can just bypass creating an account. It's that easy, you guys. And so I want to show you that as well. You guys, this is a piece of cake. I mean, look at this. So 2 seconds. Here it is. Would you take a look at this? This is the login. If you're like, oh, I don't want to put my email in though, I don't want to do anything like that. You don't have to. You see that blue button? If you want, you just click sign in through Facebook. It's so easy. And you might be wondering, well, is it pricey to watch this thing live? Like, is it like $10? I mean, what is it? No, it is just $3. The price of a cup of coffee. Come on, you guys. So we wanted to make it as cheap as possible, just because we knew it was like, well, one, it's a remote debate. I know a lot of you guys are like, dude, I would totally prefer an in-person debate, but because of the restrictions currently in place across the country, we're like, you know, I think right now we're just going to have to do it remotely. And that's one of the reasons it's like, hey, like $3, that's cheap. You can't go wrong with that. And there are different things you can do. So for example, just kind of scrolling down, now you'll see at the bottom of your screen it says, this is basically your name in the thank you ticker at the bottom of the screen. And so that $10 is just a way of basically showing more support, saying, hey, I really am excited about this event. And so it also puts your name in that thank you list. And so we really do appreciate that. But also, you guys, I'm pumped. I want to show you a couple of things. One is that, let me show you Chrome full screen. So first, we have reached 100% of our initial goal. We have bumped it up to, now it's up to $500 more. We're going to strive to get to 3,000 total. I am so excited, you guys. This is honestly going to be super epic. And so, want to let you know it's going to be epic. El Spagato said, I still don't have a Kickstarter account, but I hope that you play Never Stop by Front 242 while you do that car wash. I appreciate that, El Spagato. I will play that song, and I'll play it like it's my job. Silver Harlow says, thanks for another entertaining debate. Not sure where you dig up crazy things like this. Give me a good laugh. I'm so glad you enjoyed it, Harlow. And thanks always for being positive, Harlow. I know I appreciate when you're positive in the chat in terms of encouraging us in what we do. That means a lot. Also, oh, Tuss, you already tagged the Kickstarter in the description. Thanks for doing that. I totally appreciate that help. So some of the ideas that we're looking at is we do think that we'll probably use, man, Shivites, Jagnarth. Bro, you gotta stop spamming, man. It's like that's why people are like coming down on you in the chat, is you keep getting your stuff deleted. And for, pretty soon here we're gonna, yeah, there you go. I'm sorry, I warned you, man. I'm gonna put you, where is this? I'm hiding you, man. You've been put into timeout 300 times. If you're bringing the quality of the chat down over and over and over after being warned, eventually we're gonna say, hey, you're gonna have to create a new account if you want to be heard here. But we are super exciting, or super excited, as you guys, this is epic. On screen, that is just showing that right now we're already at over 80% for our goal of this $3,000 goal, this stretch goal. I think this is the goal. This is what I think is the best plan. We want to do another in-person debate at the Atheist Experience with Matt Dillahunty. I think that would be epic. I think it'd be really fun. Matt obviously is a phenomenal debater. He draws a ton of people. People really enjoy watching him. And so if people really enjoy it, it's like, hey, that's what we're shooting for, is we want people to enjoy the channel. So it would be in person, which means it would probably be in late spring, maybe summer, in which we would basically use those extra funds for our stretch goal to fly down there, get some hotel rooms, and then take care of speaker fees as well as the facility fees, because they do a great job at Atheist Experience Studio. The camera guys, the tech guys are phenomenal. That's why, I think that's probably one of the reasons why the debate between Matt Dillahunty and Inspiring Philosophy on our channel is the biggest debate we've ever had, with like 212,000 views. That one is a mammoth, and I think a huge part of it, in addition to the speakers, is that the video quality is phenomenal, the sound quality is phenomenal, and so we'd like to do another thing like that for this stretch goal, but we're open to ideas. If you guys have anything you're like, man, you got to totally do this, it would be epic. Other stuff though, you guys, really pumped about this. Whew. So we're really glad about that. We're also really glad about this. Let me turn it over. So you are seeing on your screen, we are on Twitch. If you have Twitch, if you enjoy Twitch, folks, you can follow us on Twitch. We are called Modern Day Debate, as you'd expect. We have the same little logo, and you can follow us, and if you want, you can subscribe. That definitely does help us. One thing I would mention, a lot of people don't know, is that if you're an Amazon Prime member, you have a free subscription that you can give to any Twitch streamer. Well, technically any affiliate, because we just became an affiliate, which allows you to subscribe now, is you can give that to any Twitch affiliate or partner, namely kind of like higher level streamers, loosely speaking. You can subscribe to them, and that helps us, because every subscription we get is $2.50 that helps the channel. As man, we've got big hopes, you guys. I'm not joking. I'm dead serious that this summer I'm seriously hoping to have some epic debates that are just monstrous, to where it would be like, wow, this channel has blown up over the summer. And so we're absolutely going for it. And then let me show you this. But yes, Amy, evidence and reasons. Oh yeah, did you guys debate before, you and Sal? But yeah, Sal's debate with Matt is going to be epic this Monday. I would highly recommend you don't miss it. I'm pumped for it. And then, as I had mentioned during the stream, if you cannot find us on your favorite podcast, shoot me an email, because we're on pretty much every single one of them. There are some where, like, I look at our podcast stats and I'm like, I didn't know we were on Himalaya. I don't remember signing, but yeah, we're on like just tons of podcasts. We've worked really hard to make Modern Day Debate as convenient for you on the go as possible. And so we really do hope there's a value for you guys. And then really pumped about this as well, though, is we just basically just today, we finally kind of upped our Teespring merch. So you'll see on the far right of your screen, Teespring. We're definitely on Teespring. If you go to basically teespring.com/stores/modern day debate, that's where we have our merch. That's linked in the description as well. If you like that stuff, we have, especially for the clothing, we've tried to knock the price down significantly. So I think it's like we make $1 on each shirt. So it's usually we would make like 14 or something, and I'm like, who would buy a t-shirt for like $26? No judgment if you would, but I'm a frugal dude, and so if you will, good, more power to you, but we want to make it as cheap as possible for you guys. Also, using our Amazon affiliate link in the description can help the channel a lot. I'm pumped about this, you guys. We've been confirmed, or what's the word I'm looking for? Approved as an Amazon affiliate. And this isn't really hard to do. It's not like it's a big accomplishment. But it is cool because basically, let's say you're going to make a purchase on Amazon and you're like, huh, yeah, and I want to help modern day debate, but let's say you're like, bro, I don't have any cash on me. I don't have any extra cash I can give to like super chats or whatever else. Like, and so you're like, well, but I would love to like help, you know, have bigger speakers on or more in-person debates and stuff like that so you can rent facilities and all that. And you're like, well, okay, so how can I help? Is that if you go to the description, under our Patreon link, there's an Amazon link. And it's like not too far from the top. If you click on that Amazon link and then search for whatever items you wanted to buy, and then you buy them, it's like roughly 2 to 3% that of your purchase will go to modern day debate. And so it's, you could call it like a portal link. It's like a link that if you use it to get onto Amazon, any of your purchases that you make after you use that link to go on, they will basically 2 or 3% of that purchase. So you're paying the same prices as always for these items that you get on Amazon, but Amazon gives 2 or 3% of your purchase to modern day debate. So that's really cool, you guys. That can help a lot. I mean, imagine if like, you know, maybe 10 people did it, and I don't know, it can add up. If enough people do it, it can definitely help. So we do appreciate that. Tuss Feedbox says the tote bags are so clean, to be honest. I'm so glad to hear about that. I do like those tote bags. They look nice. And Big Daddy Sheep New Zealand says, we all know you're a huge thrift shop blazer man. You're right about that. And G-Shot says, at this rate, we will be debating whether the moon is real or not in a few years. Hey, we should do that. I appreciate that. It's a great idea. And thank you for your support, though, you guys. Just hanging out with you in the chat is fun. And so thanks for all of that infomercial stuff. Appreciate you putting up with that. But El Spagato, glad to see you here. Do appreciate you hanging out. Spooky Bed Hair. You've been around for like since the beginning, probably. I appreciate you being here. And Skyworks 600, good to see you again. It's and let's see, is Schweitz Jagneroth still spamming? Let's see, Worldview Detective, sorry that I'm late. They said, who do you think would be debating Matt Dillahunty? This is not for sure, but there's a possibility that it would be a resurrection debate with Mike Jones, who you're seeing, no, right here. That's not for sure at all. It's just something that Mike originally wanted to do it. We would like to host it. And so perhaps this spring or early summer we would do that. And that's something that kind of depends on if both the speakers want to do it. But big deal for this Kickstarter, folks. Would highly encourage you to consider doing it, even though this is our stretch goal, because you might be like, well, hey, you already met the goal. Like, we're pumped about that. I'm honestly overwhelmed with so much joy. And I have to tell you, some of you guys said, hey, that's like a cool like way to start the year. And it's also a cool way to start. I don't know if I told you guys this, but today's my birthday. And so I didn't say it on stream because I don't want to like distract from the debaters while they're here, because I feel like it's like we want the focus to be on the debaters. That's why that's also why I kind of like try to not be overbearing as a moderator, because some moderators I'm like, you clearly are taking a side. We want the debaters to have the spotlight on them, and that's why I didn't mention it. But I'm excited. I'm 34. I cannot believe it. You guys, the time flies. It really does, and it's almost scary. Mitchell, thanks for your support. Says hit the like, everyone. I appreciate your positivity, Mitchell. That means a lot. Spooky Bed Hair, it's my pleasure. El Spagato, appreciate you saying that it's a fun gang here. I really like this channel. That means a lot. We appreciate that, and I'm so glad it feels like a fun gang. That's something that I appreciate the mods so much. They do a phenomenal job too, in addition to everybody. So not just the mods, but the mods I think are kind of like leading the way in terms of their positivity, and also Just trying to keep the chat, minimally, like, we let it get kind of like rough and tumble sometimes, but overall we try to say, hey, let's not go nuts. And so Romer says, thanks, James. Another good one. Keep it up. Thanks. I appreciate that, matey. And Tuss, thank you for your congrats. I appreciate that. Love you too. Love all you guys. I am encouraged and excited. Amy Newman, Soli, Deo Gloria, El Spagato, and X Forbidden One Gaming, and Boiled Pizza, and Big Daddy Sheep New Zealand, and Ansi Sorvisto, and Jonathan Guzman, and Human Girl. Boy, I wonder who that is. Stupid Aura Energy, and Oliver Catwall, and Colin Lorenz, and Romer, and Mitchell, and Chris O, Spooky Bed Hair Sunday Worship. Thank you for your happy birthdays. Appreciate that. And Maverick says, try to get Otangelo and Matt. I don't know if Matt's going to go for that, but he already told me basically no. So I don't know if that's going to happen, but maybe. I don't know. Thanks for your kind words, Skywork600. That means a lot. Thanks so much. Perfect one. Says, many happy returns of the day, James. Seriously, that means a lot. So I'm excited, though. Yeah, I'm 34. It was a nice day. Like I worked out. It's a Saturday, which for me, it's like the days blend together. Because like right now on break, it's like I just work on the channel, and every day's kind of the same almost, but in a good way. So yeah, it was a nice birthday. It was enjoyable. And El Spagato says, also my name is pronounced like spaghetti. Oh, so it's El Spaghetti? Is that really it? Is it not El Spaghetto? But I can say, oh, El Spaghetto. Oh, okay, that makes sense. El Spaghetto. I'm so sorry I was butchering it. The Maverick says, happy birthday. Thank you, Maverick. And, let's see. Michael, Canadian Atheist, it's true. I'm somewhat of a wee pup. J. McLaugh says happy birthday. Thank you, J. McLaugh. And I'm pumped. Yeah, so yeah, yesterday when we reached the Kickstarter goal, it was like, not only was it like, oh cool, it was a great start to the new year, but it was like a great feeling waking up today and being like, we've made it to our goal. Like, super encouraging. We also have 100 backers now, so that's really exciting, you guys. I'm going to pull this up on screen just because I'm super pumped, is that I'm just like, wow, that's amazing. So thank you guys so much. That's super exciting. We've got 4 days to go. So if you have not yet signed up to watch it live, basically here's how it works. If you sign up, whether you go through Facebook or if you create an account, either way, you'll get a message on the day of the debate where I will send you the link to the debate to watch it live. And it's going to be epic. It's going to be a party. Don't let it sneak up on you guys. I would just encourage you to basically sign up now before it's too late, as it's going to be a total bash. And so we really appreciate it. And we just don't want you to be like, oh, I forgot. Because remember, it closes Thursday. That's something I have to repeat to everybody, and myself too, or I'll forget, is that the Kickstarter does not close on Friday, which is the day of the debate next week. It closes on Thursday, the day before, at noon Central Time. So pretty, it's like, and then Mr. Anderson said, how about a geocentric sphere versus geocentric flat debate? That'd be pretty interesting. There's none of those heliocentristic. You're not getting represented. Sorry, folks. You're old news. But Sole Deo Gloria says, here to a bright and growing future to modern day debate. Thanks, Sole. That means a lot. I appreciate that. Jay McLaugh says, I'm a James too. Oh, James McLaugh? Is that your real name? Thank you. And El Spaghetto says, glasses up for James and for modern day debate. I appreciate that, El Spaghetto. Thank you very much. Super encouraging. And yeah, I am pumped for the future, you guys. So, but tell me, what's on your guys' mind? Are you guys doing all right? Did you guys have a good day? Does anybody have a story to share from your day where you're like, whoa, this happened and isn't that crazy? I'm stoked to get to hear how you're doing. Heat Shield says a birthday debate sounds cool. Yeah, it was. I had a good time today. This is a fun. Like I do enjoy this. Like I'm telling you. Like some people they watch me. Some of my friends like who see me every day. They're like, "Whoa, you're really excited when you do that." And I'm like, I just enjoy it. It just like lights me up. There's something about it that just brings me. It kind of brings me to life. It just is really fun and happy. Like the pleasure I get from it is immense. And Mr. Anderson says, congrats on meeting your goal. Thank you, Mr. Anderson. We're pumped. That's right. I forgot you can't see me right now because I've still got the Google page up. But yes, I am pumped, you guys. And so that Kickstarter link is pinned. Oh, no. Where is it? Where did I put it? That Kickstarter debate link, I just put it in the chat. And right now I am pinning it to the top of the chat. And so thanks Nate Main, who says, love how unbiased these debates are. Thanks Nate Main, I appreciate that. That's what we try to do, and so that's encouraging to hear that that's how it's perceived. That means a lot. And so yes, I am pumped, you guys. El Spaghetto said, I am now a cat babysitter. We found a stray kitten at work, and I have been taking care of him while I try to find the owner. That's really sweet. That's super cute. I love cats, and I'm so glad that you're a cat babysitter. We've got cats. Once in a while, they come on camera. This is so I'm at a friend's in the basement, and they've got cats that once in a while pop on screen. And so, there's got to be around here somewhere. Let's see. Today, let's see. I would say I woke up this morning and there was a cat like basically on top of the blankets, like sleeping between my legs because it was, I think, warm, just like basically by my knees, like snuggled in, cozy, and it was very sweet because sometimes they crawl into the bed where I am. But Heat Shield said, will you get drunk as barf for a birthday debate? Probably not. I'm not drunk right now, believe it or not. But yeah. It's so unfair, Tuss says. It's unfair when the cats come in. They just win the debate so fast. Yeah, that's true. They are super cute. And then Justin, I don't know how to pronounce your name, looks like Greek letters, said, let's see the geocentrist explain the prograde and retrograde motion of planets orbiting the Earth in his model. That's an interesting idea. I don't know if Justin, if you're watching it live now, or if you're like early into the debate, maybe you just tuned in and clicked back. I don't know. But Rue from the Dot said, love it when the cats come in or come on. I agree. Human Girl said, I got yelled at by a woman driving on the freeway. She insisted I cut her off, but I didn't. She was yelling all mental. Made me kind of mad. LOL. Did you guys like get off the freeway and then like yell at each other? Like, did you get out of your cars and like yell and say, you cut me off? That is a bummer though, Human Girl. I am sorry to hear that, and I'm glad you survived. I hope that the anger, turns to peace. Tuss Beatbox says, whenever I go to my bed, cat jumps up and screams at me until she can sleep underneath the covers with me. That's super cute. That's precious. Oliver Catwell says, that's either nice of them to let you use the basement or means that they locked you in the basement. It is, yeah, I mean, it could be both. But yeah, they've been super kind. I'm like really glad to be here because the internet's this is the most reliable place in my hometown, which I am right now for the holidays. I think it's the 4th. Monday I'm flying back to Colorado, so that way we'll have the strongest, most consistent connection for the Dillahunty debate with our dearest friend Sal. So if you guys haven't seen this, I mean, man, come on, you guys. This is going to be epic. I'm like super excited for this. Let me pull this up. This debate, which you were seeing... Oh, wait, you can't see on the screen. Now you can see it on the screen. This debate is going to be on Monday, you guys. Oh my gosh, it is going to be epic. You don't want to miss this, you guys. De Boreum said, what made you start this channel? Thanks for that question. The answer is, I enjoy it for several reasons. One, I like meeting new people. I like connecting with new people, which is a great way to do this through both the live chat. That's why I love like being in the chat during the debate too, and my attention is kind of split, but I just love it connecting with people. I love meeting the debaters. I wanted, though, probably the biggest thing at first, before I realized I'd get to meet so many people, was that basically let's see, what was it? Yeah, by the way, if you have not, yeah, it's a, well, hold on, let me stay focused. I'm like I'm all over the place. Basically, I wanted to do a channel where while I'm putting new footage onto YouTube, I'm simultaneously learning. And so I didn't really want to do a lot of editing. I thought this would be the best way to do it because I could listen to the debaters and simultaneously be putting content on YouTube, which is like I get to learn while I'm also, you know, kind of doing the YouTube thing, which I've always loved YouTube. It's always been like the most fun for me. Like I've just totally enjoyed it. So thanks for that question. Perfect One says, if it's James' birthday, what does he seem sober? I'm as sober as a judge. El Spaghetto says, James, blink twice if you're being held hostage in that basement. You could kind of say that. No, it's honestly, I love this. It's great. It's a little bit, you might be able to hear the furnace, but it's all right. Human girl might get a cat. Good for you. And she says, no, the lady, she went off the freeway. She took a turn, the coward. Well, that would have been interesting, I'm sure. I'm sure you guys would have been buddies. El Spaghetto says, I can't wait. Sal is super pleasant. He is really pleasant. I think Matt will really like him too. Dorifor, thanks for being here, said, I'm really late and I'll watch the debate later, but doesn't an infinite universe preclude it from even having a center? That's an interesting question. Juicy. And yes, I am pumped though. Human Girl says, hey James, how is Natalie? I talk to Natalie once in a while. Nathan, the word on the streets is that he's started a new YouTube channel. So, Farron Salas, thanks so much for updating your pledge. Said, I just updated my Kickstarter pledge just now from 40 to 60. That is like super kind of you. Seriously, that's super encouraging. I'm really excited for it. That's so cool. So thank you, really, for real, Farron Salas. That's encouraging. I'm pumped for it. I'm just like, wow. I'm excited. I think we can reach this stretch goal of 3,000. That's not too far away, and I think we've got a lot of debates coming up in the next several days that I think are going to help get the word out about it, and so I think that'll help and definitely, you know, kind of make it grow. So appreciate your support, you guys. That means a lot. And oh, so sorry. I'm like so sorry. I'm like so behind on the Twitch. I'm trying to switch back and forth between the Twitch chat as well as the one on UT, and thank you for your kind words. Said, best birthday gift. I appreciate that. Your kind words mean a lot. Seriously, for those of you listening on Twitch, I really, it means a lot. Ms. Metal and Polar TT YRTM Gorbachev, thank you for your cat pictures as well. But yeah, I'm pumped, you guys. Ansi Servisto, thanks for your super sticker of a birthday cake slice. That's super kind. Well, thank you. Seriously, that really does mean a lot. I mean, it's encouraging. See, Farron Salah said, I would like to see Capturing Christianity and Matt debate. That would be a juicy one. No doubt about it, Farron Salas. That would be really cool. And Human Girl says, champion. Oh yeah, Heat Shield, we are on Twitch. If you guys didn't know, we are definitely on Twitch. We're live right now on Twitch. And I will even put the Twitch link in the description in case you have not already been there before to see what it's like, as if you've never seen Twitch. But I'm pretty sure you have. But this way it's easy to find us if you want to click follow. And then I think if you click follow, it'll give you reminders of when we're live, right? So I'm putting our Twitch account and I'm pinning that to the chat next. So that is in the live chat and also pinned to the top. And Tuss Beatbox, yes, fashion advice for today. I still think layers look great. So even though this is like a single, you know, technically it's like 2 layers, I like outfits with layers. That's my best general suggestion. I highly recommend wearing plenty of layers. And El Spaghetto is right. You can support the Twitch channel by subscribing. That definitely does help us. And so if you have a subscription or if you want to do a new subscription, doing that there is a great way to do it. We really appreciate that. Basically, as if you didn't know it, you guys, if you have Amazon Prime, you can already subscribe to our... if you're on Amazon Prime, you get a free Twitch sub that you can use on any streamer that allows you to subscribe. And so I would encourage you folks, like, hey, like, what are you waiting for? I mean, I would definitely don't let it go to waste, because that's helpful like that to us, and it doesn't cost you a thing. If you've already got Prime, folks, if you've already got Prime, you've already got that sub for free. You might as well use it. Now, I am also linking in the chat in just a moment. But yes, Tuss Beatbox says, how to use Amazon Prime to subscribe on Twitch. She has shared a mini link. Thanks so much for doing that. We really do appreciate it. You seriously rock, Tuss Beatbox. So there's a link there that Tuss just shared in the chat, showing you, explaining to you how you can subscribe to a Twitch streamer such as us using Amazon Prime for free. So it's not an additional cost, but when you subscribe to us, it does support the channel, and so we appreciate you guys doing that. If you're willing to put that little bit of time in, it all adds up, and so we're excited about that, and we appreciate that. And thanks, Tuss Beatbox. Appreciate your kind words. And but Big Daddy Sheep says, Big Daddy Sheep New Zealand says, layers like an onion. No doubt about it. Now, this link, or I should say this page that I'm showing you on Chrome, which is currently showing on the screen right now, this debate this Monday, it's free to everybody, so you don't have to pay a dime to watch it or anything. There's no pledging or anything for it. This is our way of saying thank you for everything. Human Girl said, James, do you like the show The It Crowd? I've never actually seen it. You'd have to tell me more about it, because I'm new to it. But I want to mention, if you have not yet, you guys, that link between, or I should say the debate between Matt Dillahunty and Sal, that's coming up fast, you guys. And it's showing on your screen, and I am putting a link for that debate in the chat so you don't miss it, you guys. I'd highly encourage you to check that out. It's going to be epic. And Tuss Beatbox sent me a link. It's still loading. That's how old my computer is. But we're going to make it. But yeah. It's still loading. Is this some sort of tasteless joke, Tuss? Just kidding. It's alright. Let me see here. But yeah, I'm pumped. This Monday's debate is, I think this is going to be a gigantic one. Like, we love gigantic debates. Who can blame us? But yeah, I'm pumped, as I think this is going to be an especially big one. And oh, that's super cute. Thank you, Tuss Beatbox. It says, we love you, James, and it has a picture of an adorable cat. Is that your cat, Tuss? I'm curious if it's your cat or if it's someone else's. Super cute. Jamie Russell says, hi James, modern day debate, hope you had good holidays. I hope you did too, Jamie Russell. That seriously means a lot. I really appreciate it. Oh my gosh, that's the cutest thing ever. I'm seeing now that the cat has a necklace that says "Happy Birthday, James." That is the super cutest photo in the world. That has to be your cat. She even has this sign for you. Sorry, the picture was loading so slow. It was like when it gradually like shows from the top down to the bottom. Um, that's so funny. That's the cutest thing ever. Thank you for making that sign for me, and thank you to your cat for doing that. I appreciate that. That's seriously really sweet. And that's so cool. Let's see. Human Girl says it's so good, James. You mean the picture of the cat? I definitely agree. That is like the cutest picture ever. So I appreciate that. And John Maddox, I will be in touch with you. I definitely will, as I appreciate your support and your help. And oh, you're talking about the show Human Girl. I see what you're saying. The show that you told me to check out, The Italian Job. Do I look like someone from that show? I used to, not always. Once in a while, I would hear I look like Sylvester Stallone, maybe. I don't think so. But do I look Italian? I'm a bit French, mostly German. And yeah, but thank you, Jamie Russell, who says like and subscribe. I appreciate that. And please do hit that like button and subscribe. If this is your first time here or if you're digging this, Jamie Russell, thanks for your support, says one up. Thank you. I'm like big on retro video games, so I do appreciate that. And let's see. Smokey Saint is kicking off his open mic. If you could give me a shout out, Modern Day Debate, happy birthday. Thanks for your happy birthday. That means a lot. And that sounds juicy. So if you guys want to harass Smokey Saint, now's the time. He's going to have an open mic. Evidence and Reason says, I'm embarrassed to say this, but I just subscribed to Modern Day Debate. Sorry for my delay. That's funny. We're thrilled to have you. Thanks so much, buddy. Appreciate that. We're excited about the future, and it will give you reminders of, I mean, that's the thing is like, if you ever see it gives you a reminder, I would remember if you are subscribed, click the notification bell just to see that it actually gives you reminders, because sometimes YouTube will actually, I don't know if it's on purpose or not, but they will like turn it to where you're either not getting reminders or you only get some reminders. So if you want reminders for every debate, which I'd recommend, because then you can just kind of peek in and you're like, do I want it? And like, nah, not that one, forget it. You just watch something else. Or if you like it, you're like, oh, glad I knew about it. So don't forget to hit that notification bell. And thank you, Tuss Beatbox, for your encouraging words. Says hitting the like makes you 20% cooler. I mean, it might even be 25%. I don't know. I was like, but yeah, thank you guys for real. Seriously, I'm super encouraged by you guys. Thanks for your birthday wishes. Thanks for your kind words. Really appreciate you guys. I'm so pumped for the future. Where I'm telling you guys, we're gonna do big things. I'm excited about it, and I appreciate that you guys are like 100% in. That we are doing it as a team. We're doing it together, and so thank you so much. Appreciate all of your support and kindness. And so yeah, I will see you next time. I hope you guys have a great rest of your, was it Saturday? It's Saturday. So Human Girl's right. I do have 90s internet where it loads like like little like rows of the picture like all the way down. And Adam Elbilia, glad you made it, party person. And FFKKFF says, happy birthday. Thank you, friend. I totally appreciate that. And MP Empressive, thank you for stopping by and says, so is the debate happening tonight? This is the after show. This is the post-credit scene. It has already happened. If you scroll to the very start of this stream that's currently going, it is on there. And Heat Shield says I'm exactly 2% cooler, but Birthday Boy is 102% cooler. That's funny. Appreciate your kind words. Colin Lorenz says, cheers, James. Have a great rest of your birthday. Thank you. Appreciate that. But yeah, partying too hard. I can't remember what day it is. You're right. FFKKFF. I'm pumped. Thank you guys. I'm encouraged about the future. You guys, I absolutely have so much optimism for the future. It's going to be great. You guys believe me. I'm going to be working so hard, and I'm going to be enjoying it. I mean, that's the trick. Is like I love what I get to do with this channel. It's so fun hanging out with you guys, meeting new people, new topics, like all sorts of. I'm just an idea person. I thrive off enthusiasm, and so I appreciate all your guys' enthusiasm and love. And let's see, Mipreziv says, "Awesome, thank you, sir." Well, thank you, sir. Appreciate your kindness. And Deborium says, "Happy birthday day, James." Thank you, appreciate that. Jamie Russell says, "We are related." You serious? Preziv says, "Happy birthday and New Year, James." Thank you, friend. I appreciate that. Happy New Year to you. And Human Girl says, "Bye with a rose." Thank you. Peace all, perfect one. Thank you. Awesome. Happy birthday, my friend, from Adam Albilia. Thanks, Adam. Appreciate that. That means a lot. Good to see you, buddy. I hope you're doing well. And yeah, feel free. April Dawn says, "Happy birthday." I didn't know you were out there, April Dawn. Thank you for saying that. That means a lot. And but yeah, I'm pumped, you guys. Let me know if I can make your life easier. For real, like I do. It's like the joy and the community and the satisfaction and excitement and just the thrill I get from doing this channel with you guys is like, it's a total thrill. I appreciate you guys so much. Please do let me know if there's something I can do to make your day better, you know, like for real. Reach out. I'm at moderndayDebate@gmail.com. I hope that I can be a blessing in your life, and that I can just, you know, help you, or if there's anything you ever wanted help with it, or if you if there's any way I can make your day better, please let me know, as I appreciate you guys. And so with that, Josiah Hannah says, "Post-debate chats with James are the main reason I watch, to be honest." Josiah Hannah, that's the nicest thing ever. Thank you so much. That's super encouraging. I really appreciate it. And Net7, thanks for your super chat. Really appreciate that. Said super sticker, I should say. Said you were amazing. That seriously means a lot. I appreciate you guys. So really do appreciate it. And Tuss Beatbox says, "You're generally making lives easier already. The community, the entertainment, the way you expose people to new topics, the way everyone can learn from the debates. You are doing so much, James." Seriously, that means a lot. That's encouraging. That really kind of puts the wind back in my sails. And so, April Dawn, thank you for your kind words as well. And Heat Shield said, "I'll DM you with some ideas. Happy birthday, bud." Thanks, Heat Shield. It seriously means a lot. I'm totally encouraged. So yeah, thanks so much, you guys. I hope you have a great rest of your night. Jamie Russell says, "May God bless you all. I truly love you. Good night." Yeah, I hope that across boundaries, so to speak, boundaries of like groups, you know, it's like, oh, like that person's a Christian, that person's an atheist, whatever. I do hope you realize we all have something in common, which is we want fair debates. It's like, hey, that's one thing we can say we're happy we've got in common, right? And so I do hope that we are together on that. I think there are other things too, though. I mean, like we all, you know, we enjoy debates. That's something we have in common. I hope that you guys feel connected when we do like our charity streams. So like we're doing one on, I think it's Wednesday or Thursday. Thursday, yeah, we're gonna do it Thursday. Is that I hope that unites us too, where it's like, hey, we want to give to a good cause, and you know, that's something that no matter what walk of life we're coming from, we can agree that like sending money to like provide clean water for children around the globe is a good thing. We all agree is a good thing, and we're happy to give to. Like, so that's like a cool thing that I hope that kind of unites us as well. And so I do appreciate you guys, no matter what walk of life you're from. And so thank you guys. But yeah, thank you guys. I should go. It's getting late, but I hope you have a great rest of your night. Thanks so much. Keep sifting out the reasonable from the unreasonable, and appreciate you. Take care. And I will leave you with this epic picture, as I am like, seriously, yeah, I'm excited. You guys think I'm like messing around, but like I said, where did it go? Wow. I'm pumped with this one, you guys. I'm so excited. It's a new topic. I think what we're going to start doing more often is exploring, this is the last thing I'll say, sorry, is that we want to explore specific arguments. So we might have more debates more often that are specifically like, is Pascal's wager a sound argument? Is the Kalam cosmological argument sound? Is the problem of evil sound? We're going to do more like that. So thanks so much. We hope you have a great night. Keep sifting out the reasonable from the